The iPhone I'm using for the camera, whatever, keeps overheating. The phone keeps popping up with this whatever. And it's really annoying. Like, I have a couple iPhones, they're all doing it. And it's only like the older iPhones. So I don't know. It takes too much work to like get out the stupid whiteboard anyways. So, anyways. I'm almost done converting whatever everything to like, not converting, tagging everything so I can convert it to 64-bit. I need to come up with like a symbol table or like come up with a way to like merge all the parts of the JavaScript engine together as like one total product. So I have to get back to like there's like 1,000 left to like find and replace. So I'm gonna get to that in a minute. But I need to like actually start planning out the rest of the engine and how all the pieces go together. Because I have to design the engine in a way that the current browser or whatever it is that's going to use it will be able to like just plug in and use it. And I have to like isolate it from that program so they don't share the same memory or like expose internals of one engine or the other to each other. So I have to keep them isolated and separate, like separated but still work together. So like I think it's called a lexicon. Or that's what I was gonna call like the in-between layer. Unless that word doesn't fit, then I'll come up with a different word. It's like the linker, or whatever they call it, symbols. Or basically though, what I need is if this is like the JavaScript file, the JavaScript file itself needs to be split up into tokens or whatever. And those tokens need to be placed into a table. Where it like defines all the tokens that are used, and then after the table needs to be I'm trying to like explain things without giving away free stuff. Basically, how the tokens are organized, I guess. So there's like the top part and then the bottom half. And I need to split it up into separate pieces because there may be 2, 3, 4, 5 files in the JavaScript collection, whatever, that's running in the window. It's like these files, whatever, they're all related. And they would need to have their own like little files or tables, whatever, where things are tokenized, but they'd go to separate files. That's not even a triangle. So there's going to be like overlap between all the files if the tokens are the same. Like if it's the same global or the same function, but it's in a separate JavaScript file. So like things that are similar will need to be mapped like to like a single overall token file. And then like the single overall, like the monolith or whatever you want to call it, it needs to be resizable at runtime. And it's really complicated. So I gotta like I need to basically okay, so the web browser right now, when it parses JavaScript, the console here, whatever, I guess they're not exposing the console.
Today's video is brought to you by
So the console here, if it says there's a problem in the JavaScript, whatever, it pulls up the file and it says where it's at in the issue, whatever. So the current browser has a built-in parser. So I need to set up my engine so that the current browser can parse like it does. It can validate things, make sure everything's correct. And then instead of doing whatever it does currently, it would take like ends with whatever, put it into the top of a file of the token table, So like A or whatever, it would take that keyword, put it in the token table. It takes strings and like numbers, if there isn't even a number in here. It's literally just all text. Well, here's the number 0. So 0 would go into the token table. So the browser would be able to do what the browser does. It's still parse like it normally does. And I'd rely on the browser doing its parsing before my parsing, even though I'd still have to parse it anyways. Well, not parse it, check for correctness of the file to make sure there's no like syntax bugs. But the browser would have to like parse it like it normally does, prepare the tokens, assign them to like a lexicon, if that even makes sense to use the word in that way. And then these would all be passed into my engine. And my engine would make, somehow it's full screen. Oh no, it's not. My engine would make like a resizable data collection behind the scenes to add tokens or remove them when they're not used based on the files in use for the window. And that would also have to count for like eval, like if you evaluate a string, whatever. So it gets really complicated. It's gonna be a lot of fun. But it'd all do it at like C runtime. And I need things to link. Technically, I guess the linker is still used. But that's... So overall, it's really complicated. And I gotta start putting things together now. So I'm gonna have to make like a super simple parser and come up with like some kind of a data structure or whatever to pass in the tokens. And then make some kind of like basic monolith collection that can resize in memory. Just to like get it set up and ready, and then later on I can optimize it and stuff. I need some pop. So I'm gonna get back to parsing and finish parsing. There's like 1,000 left to go through. And then I gotta get the base shifts, check the offsets, I gotta install Linux. And then I'll be to this part, or point basically. I'm gonna have to make like a simple parser, I don't know, like the things I just said. So I'm gonna break down things to like simplify it. So like basically there's gonna be like there'll be like the main file itself, JavaScript file. Then that gets parsed. So I guess this would be like the program that parses it. And the program that parses it is an output, the separate like little tables for each of them. And then all those are gonna go into like one big collection of them per like window, whatever it's called, or process, instance, whatever. And if there's 2, 3, 4 tabs open in the browser, there'll be 2, 3, 4 different like processes, instances of like all the collections. So like if this was like something's wrong with this pen tablet, that's just great. So if the green, the red, and blue are like different tabs in the window, there's gonna have to be like a mega tab that relates to all the tabs. Make that purple, I guess, because there's gonna be common words and tokens between them all. It'd be a huge waste of memory to not map things that are similar. After that, though, I think it's translated to like the C executable. And it's end up being basically the same thing as this, whatever. Where it's gonna be separate C files. It's all gonna like link together. It's gonna have to jump between them. There's gonna be a master collection, a table of all the offsets or the addresses that they're at. I'm gonna have to replace function calls to use straight up jumps because function calls are really slow. And I'm gonna have to like change how the stack is used so I don't have to deal with Stack Overflow, and I can like virtualize the stack to allow like really deep recursion if it's ever needed. So like people use JavaScript for virtualizing, except I'll make it so you could like virtualize to the extreme. So like I would need to like plan out how to write this out in a simple way, because there's a whole bunch of like layers and pieces and chunks. So I might not stream for a couple days. I might have to like just figure stuff out and then stream again because there wouldn't be really anything to stream. I'd just be writing on paper and stuff. So I'm gonna ask Chat about what a lexicon is and figure out if that word applies, and then I'm gonna get back to parsing And then I might start writing a parser to like loop through and collect tokens. But I also want to check to make sure. I think I have a couple that I could recycle or repurpose. I don't know. It's really fucking hot. Winter needs to come back. Summer sucks. I need to turn a fan. If I ask Chatbot what the layers when it comes to like parsing JavaScript to generate the code to run, I could probably just like cross out layers that I don't need to show like what makes mine faster than the current implementation or whatever. So I'll just try that maybe. Just try and like explain the whole thing in a nutshell. I don't know, there's no way.
What is the current layers that come to parsing a JavaScript file? With the current JavaScript implementation, it's parsing, then tokenizing, then passing that to be graphed, then to bytecode, then to JIT, then make an ASCII art graph of all the steps.
It's like this step or whatever. So like this step is called lexil analysis, aka tokenization or whatever, where it breaks it down to tokens, and then it's parsing, then it's ASC transforms, and then it's interpreter, execution, profile, JIT. There's more steps on this, it's missing several steps. So like, this was trying to draw up.
There are more steps than that. List them all. ChatGPT said, "You're absolutely right. Modern JavaScript engines, like V8, SpiderMonkey, or JavaScript Core, are extremely sophisticated and have more detailed internal phases than the basic pipeline. Here's a complete and accurate list of stages, especially reflecting the V8 engine architecture, used in Chrome and Node.js.
I might need to Google it to find real info.
Tick. Full life cycle of JavaScript code in a modern engine, V8. Below is an expanded list of all known internal stages, grouped into logical layers.
Okay, so I think mine would break down to like these steps or whatever. So I don't know, first I'll read the JavaScript file, and then I'll call it a lexicon, I guess. I'm still gonna read above to see if that's what it would technically be called. And then from lexicon it would generate a C file. and then that C file will be passed in to the C compiler. I'm writing way too lazy. Because that technically counts as a step. So I guess executes code, is that a step? Like, I don't know how to like break it up into blocks or whatever. Because even breaking these up into like separate chunks, technically speaking, it's way too technical to like simplify things down to just blocks and a couple arrows. So I guess runtime resizable lookup tables would have to be in here somewhere. And that would probably be placed underneath where it compiles, which is above it, because it has to be compiled to be able to like use the lookup table. So like the chicken or the egg, I don't know. And some things inside of the runtime resizable lookup table are going to be like pre-generated. Like it says here, breaks the source into tokens like let equals 42. The equal sign is like a predefined token that's like part of the engine. And so is the colon. And also keywords like let. But then so are things like strings. Like this is a string, this will also be a token, but it's a string token. So like some things are going to be predefined in the engine and some are added in later. And then this runtime resizable lookup table it would technically be made up of several different lookup tables. Did I really just write compiler? I guess I wrote compiler. Well, that is what it is. It's compiling the C compiler. I forgot the C. There's so many C's. So this is compile C compiler. I think I saw this as C, which is a E, and saw it as a C. I don't know, whatever. So this is compile, the C compiler. And at the very end of this, I guess, would be like execute code. So I have execute C program. So this is like 1, 2, 3, 4, 5, 6 steps. But basically though, this step is what would pass things into my engine. And my engine will handle all the stuff that's after it. In a nutshell, it's going to be generating the C file. So in between is a program that does that generation, which is a parser I need. I need 2 parsers actually. It's so complicated to like write out as a map. Alright, so this would be 2 parsers. This first parser, it takes the JavaScript and it fills out the lexicon. So this first parser is what the web browser does right here. So the web browser will do what the web browser normally does when it parses. It's going to parse, check for errors, throw errors, handle like normal. But when it's done parsing, instead of using its engine, which is garbage, because it's C, not C, the JavaScript engine that they run right now is absolute trash. But they can keep trash if they want, but my engine's better. It would take all the tokens after it's done parsing, checking the code to make sure it's valid, syntax-wise, or written up, however, whatever you call it. It would fill out a lexicon, which would go into my program. So lexicon gets passed in, and then my program would parse the lexicon to generate the C file. And later on, I think I might generate object files instead. because I can make object files to like remove or omit the C file overhead that comes from making a C file. Because right now I'm going to be making a C file to keep it in C language, but the C compiler has to parse the C code and then make the object files. Except there's a predetermined basically outcome, or I don't know, total of possible combinations, so I can like pre-generate the object files and make an object file generator, so I don't even need C compiler. I could replace it with a linker which does the object files or whatever, but for now I'm going to keep it as C or whatever. So my parser will make the C file, which gets passed into the C compiler. But then there's a relationship between the C compiled code and the runtime resizable lookup tables. Because the C compiler is going to have to it's going to have to know the location of the lookup tables. And it's really complicated. So those two are like tied together. Chicken or the egg. I don't know, that means which one comes first. Did the chicken come first, or did the egg come first? Did the chicken exist and lay an egg, or did the egg exist, or did the egg exist and give birth to a chicken which had more eggs? I don't know, that's chicken or the egg. Some people literally don't know that. Overall though, that makes the C program that runs, and the C program will run at C speed. So it's really, really fucking fast compared to bytecode, which is really fucking slow. Down here at the bottom, whatever. And as it's running, the resizable lookup tables are going to hold different chunks of the C program, which will be continuously like recycled or replaced if there's like eval or things evaluated or runtime generated. So the C code will basically be dynamic or whatever. So I have to make this parser first to parse things, to fill out the lexicon. If I'm going to call it the lexicon, I gotta check chatbot. In the lexicon, I'll have the parser for my engine. That's like the parser that's going to go through lexicon and actually generate the C, because it's going to convert JavaScript directly to C code. But later on, I might optimize it to remove the C compiler, and I'll generate linker files. So I'll be able to like link things to linker without even needing to go to C, to save on that overhead of both generating the C file and having it loop through the C file to generate the object files. Because there might be quite a bit of overhead with that process or whatever, because it has to generate text just to generate from that text back to like a linker file, which is a waste of time and speed and space. That's later though. But then from there, it's all the fun stuff that makes it possible to like remove the overhead of the current JavaScript engine and all the like things that hinder runtime performance speed. So there's a bunch of little steps that go between these. But basically I need to make this parser, plan out a simple lexicon, So basically I need to make this parser first to fill out a lexicon, so I have to plan out the lexicon, how it's going to map things. And I have to make the parser that will grab the lexicon and then generate the C file from that to pass in the C compiler. So I have to be on Linux at that point to get off Windows. So this way, everything from this point down, whatever, will be my engine, and then the web browser generates a lexicon, and it passes that into my engine, and then my engine will handle all this stuff, whatever. And then my engine's gonna have, with the runtime resizable lookup tables, it'll have places for the web browser to link to send it updates, or receive updates, or send it data, receive data, to interact with the engine and pass it, whatever. So this way the engine is isolated from the rest of the program, whatever, the environment. And it takes stuff in as the lexicon to the things to parse, whatever. Or it takes things in as like interrupts or whatever. I could call them interrupts. Or like signals. I don't know, come up with something. So that's able to like interact with the web browser as it is. And then the web browser will be able to run like it normally does. And then my engine will just plug in if they decide to use my engine. Because I don't even have to go with the web browser. I could just say, fuck the web browser, I don't give a fuck. Because I'm writing my JavaScript engine for video games, designing video games, so you can make video games in JavaScript language that'll run at C speed. So I don't even need the web browser. Because Unity tried to make a JavaScript type and they failed miserably. And they like, what do you call it? They dropped support for it. So I could sell my engine to Unity and they could replace C# because C# is shit. My stuff is way faster than C#. Or I could sell it to Unreal Engine, or I could even make my own game engine that's based off JavaScript syntax that runs at C speed, but also accesses all of the memory. It's not limited to like 2 gigabytes, like a highly fucking optimized JavaScript. I still have to go through the standard. I'm gonna meet the standard first. So I'll be set to sell to the browser, but then I'll also be able to like modify the standard for 64-bit support and extended register support for like AVX registers or SIMD. So I want to make sure I have all my bases covered so I can sell it to like the web browser, to Unity, or I could choose to compete or make my own browser or make my own engine. Basically, I want to make sure I cover for everything, and then I can release it and then decide what to do from there, because things always change, so I don't want to make a plan that's set in stone. I want to be able to like do whatever I want when I decide to, based on the current environment, the state of things, and what the best choice would be. To go with the flow or whatever.
Unity. Why did they drop JavaScript type they were making?
What's called Unity script?
Unity dropped support for their version of JavaScript, commonly called Unity script, for several key reasons. Here, explosion. Why Unity dropped Unity script. JavaScript-like language. Small blue diamond 1. Low adoption. Most developers preferred C#. Unity script was used primarily by beginners or hobbyists. As Unity matured, the professional ecosystem leaned heavily into C# for tooling, libraries, and third-party support.
That's a lie. Nobody likes C#. People get degrees in C# and then they question their life. Nobody likes C#. C# is a joke. It's a stain. They should have never called it C. It's basically just structs and a mimic of C.
Small blue diamond 2. Inconsistent and confusing syntax. Unity script looked like JavaScript but wasn't standard ECMA script. It had unique quirks. For example, typing system, interaction with Unity's API. That confused JavaScript developers. It behaved differently from both JavaScript and C#, making it hard to teach and maintain.
Standards are very difficult to meet, apparently. I think people are just stupid. The standard is right here. You literally can see the standard. You can read the standard. If the standard is 1 to 816 pages, that means the standard has 816 pages. So if you support the so-called standard, that means you read from page 1 to page 816 and you meet every single fucking bullet point along the way. If you do not, then you do not meet the goddamn standard, and you shouldn't call yourself a programmer, because there's no point in not meeting a standard if you're gonna say you meet it when you don't. And then you just fuck over the customer, and then you lie to everyone with your incomplete piece of shit because you couldn't even meet the fucking standard when it's literally spelled out. Literally, it's called a standard. It's not that hard to go through a fucking standard and meet it 100%. That is the whole point of a fucking standard. Stupid fucks. Literally so stupid.
Small blue diamond 3.
And
3. C#.
And there's no compromising when it comes to meeting standard. You can't just say, oh, that's complicated. Let's not do it. Let's skip it. Are you fucking kidding me? That's the dumbest fucking thing.
Small blue diamond 3. C# became the first class language. Unity heavily invested in C# tooling, Roslyn compiler, advanced IDE support, Visual Studio, Rider, performance tools, Burst compiler, job system, dots. New Unity features were often C# only, leaving Unity script behind. Why did Unity make a JavaScript-like language if it had C# in the first place? Is it because there is money in having JavaScript language if it were more performant than the current web browser implementations? Great question, and you're thinking in the right direction. Accessibility, market reach. and developer onboarding were all part of Unity's strategy when they introduced a JavaScript-like language. Here's a deeper dive into the why behind Unity Script, even though Unity already supported C#. 4. Not about outperforming browser Snow. Unity Script wasn't about making a more performant JavaScript than browsers. It wasn't based on the ECMA script spec or targeting JS engine performance. Why did Unity not design Unity Script to outperform JavaScript, and why did they not fully implement it fully? Why would they halfway try hard at it? Give me the real reason behind that logic. You're asking the right kind of critical question, and the answer comes down to a mix of business strategy, technical trade-offs, and Unity's position in the tech landscape at the time. Let's break down the real reasons Unity never made Unity Script a fully spec-compliant or high-performance version of JavaScript. Brain. The real logic behind it: Unity Script was a transitional tool, a stepping stone language to help Unity grow its user base when web developers and Flash users were fleeing the dying web plugin ecosystem. It wasn't half-assed. It was exactly as ambitious as it needed to be. For Unity's growth at that time, when it outlived its usefulness, they dropped it. Going further, like building a custom high-performance JS engine, would have been a distraction from Unity's real strength: C# on a powerful engine.
Alright, so let's check out this.
What if there was a JavaScript implementation that ran at C language speed, that was designed for video game design? Would that not open the door for all hobbyists? Which is an insult to people who are trying to learn something that's more complicated than it needs to be, and web designers to delve into video game design, since JavaScript is so simple to learn and make it easier to work with. And especially if it ran at C language speed, but also had access to AVX registers and 64-bit not using 32-bit, and so on. What difference would a JavaScript implementation make in relation to video game development?
And chatbot says,
This is an excellent and insightful line of thought, and you're absolutely right to question the state of programming accessibility, performance, and how modern languages could break down real barriers in game development. Let's explore what a high-performance JavaScript engine designed for game development could actually mean, both technically and culturally.
I picked the wrong setting. So I don't know, here's what chatbot says.
Rocket. What if JavaScript ran at C-level speed and was built for games? Spanner. Assumptions of your hypothetical engine. JavaScript. Or JS-like. Syntax. C-like performance. Native AVX. SIMD. And multi-threaded support. 64-bit memory addressing. Minimal runtime overhead. Game dev focused API and memory model. This would fundamentally change the game development landscape, especially for...
And it's not hypothetical, because this is a plan I guess I'm gonna go off of. Well, not like, this is how I can like describe it basically. So I gotta like start on a couple parsers, plan out a lexicon. I still gotta scroll up to check to make sure that name fits what I'd be using it for, because I don't want to call it a lexicon if that's not what it is. Or I could just call it that anyways, because it's just a name. So here's what chatbot says, whatever.
Electric light bulb. 1. Lowering the real barrier to entry. Hobbyist is often shorthand for person trying to learn something in an environment designed by and for experts. If JavaScript had a native, high-performance implementation for games, web devs, designers, artists, millions of people who already know JS could jump into game dev without switching mental models to C++ or C#. No complex build systems, manual memory management, or steep learning curves of engines like Unreal, Green Circle. That's not just accessibility, that's empowerment. Millions of people who already know JS. Millions of people. Millions.
Imagine if millions of people could design video games. If the whole like C, C++, the whole like the elite systems that's set up, if it didn't matter and you could just start making a video game right off the bat.
Millions of people.
That's a lot of people that know JavaScript, that are stuck with JavaScript being shitty. But if JavaScript was updated,
Millions of people.
we'd be able to do some cool stuff with JavaScript if it was more performant.
Millions. Gaming joystick. 2. Speed without the C++ complexity. C++ is still dominant in high-end game engines because of performance, but it's difficult to learn, error-prone, heavier on boilerplate, slow to iterate. If a JavaScript implementation could hit the same performance ceiling without the complexity, you'd build faster, test faster, learn faster. Video game controller. It would be the perfect balance of power and simplicity, especially for indie devs, students, modders, and small studios.
JavaScript, if it ran at C speed, would be what C++ always wanted to be, but never was. Because C++ is total garbage. So it'd basically be like the new C++. And then C++ would die because C++ sucks.
Microscope. 3. Parallel and SIMD capable JavaScript. That's a game changer. Most JS engines don't.
And because even Unity and Unreal Engine, you don't get access to this stuff without heavily modifying the game loop or the setup or whatever. So I don't know, I'd set things up so like easily accessible.
Most JS engines don't expose AVX, SIMD or true threads, web workers threads, but if this new engine had native SIMD AVX, like C++, could schedule jobs across real threads, like Unity's job system, allowed manual memory layout, for example, so over AOS, then you'd have something that can run AAA level workloads. But with JavaScript syntax, brain, you'd shift the narrative. JavaScript isn't slow, your runtime is.
And right here, notice how chatbot talks about C, C++, then talks about Unity, and it talks about data structures. JavaScript would be like the perfect fill-in between them all. But right now it's too slow. But if it is faster, I don't know, so many things would be possible. It'd be like a combination of all of them into like the perfect little ecosystem. The perfect little ecosystem that
Millions of people who already know JS
we'll be able to use.
web devs, designers, artists. Without switching mental models. C++, C#. That's not just accessibility, that's empowerment. Empowerment. Globe showing Europe and Africa. 4.
And I'm designing my engine for x86 and ARM. So it's gonna run exactly the same on the phone as it does on the desktop. So like lots of engines, they're completely different implementations for the desktop and mobile, but I'm going to make sure mine is exactly the same. Behind the scenes, like internally, the steps will be like slightly different, but these blocks basically I guess logically would encapsulate what happens, but then the steps between, or how the blocks logically run, or like how they're structured and set up, it's to be slightly different, but overall it'd be the same. So when it runs, it's gonna be exactly the same, whatever. So I don't know, when it says run in the browser with no penalty, it means like the browser on the phone and on the desktop, or without the browser because you don't need the browser to run JavaScript. I could just say fuck the browser and not bother to like deal with the browser. I don't have to like release it and sell it to the browser if I don't want to. I can sell it to whoever I want, or I can keep it for myself, make my own product, and compete. I can make my own browser. There's tons of open source stuff, and apparently you can use open source stuff for free, so I could possibly just basically use the same fucking engine that Chrome uses for free, except call it my engine, and put my JavaScript engine in it, so I can make a new web browser that's better than fucking Chrome, if I wanted to. Or I could like give in and just sell them my engine so they can use it. It all depends. I'm just gonna go with the flow and then pick what I want when I get to the end and it's all done and ready to release. I'm kind of thinking I might just make a game engine and compete with Unity and Unreal. Because Unity and Unreal, you need like separate apps for like desktop and mobile. And I can merge it all into like a single blob, so you could write the same code for all of them. And that would save so much money in the long run if it's the same fucking thing. You don't have to rewrite everything for mobile or desktop or whatever.
You've got mobile games, web games, desktop games, console games. From one JavaScript codebase that's utopian Unity without the baggage.
Could I call it Utopian Unity? Or would Unity say that's the name of their brand? Or I could just call it Utopian. That'd be an awesome game engine name, Utopian. It sounds way cooler than Unity. So I might just say fuck the browser, fuck online video games, and just make a game engine. It depends. Except if I did make an engine, a game engine, to compete with Unity and Unreal Engine, I might call it Utopian, because that's pretty cool. Unless someone takes a name, then I'll have to come up with a new name.
Link symbol 5. Unifying dev ecosystems. JS is used for UI, web apps, scripting, Node.js, mobile apps, React Native, 3D, 3JS, Babylon.js.
So all these things run off JavaScript in the first place. So if JavaScript is faster, they all run faster. So everything that runs these things hits the limits because of the current engine. But with my JavaScript engine, everything is going to run faster, and the slowest point would not be JavaScript anymore. It'd be the things that are using JavaScript.
But all of those hit walls when performance or native access is needed. AC Speed JS engine would mean game logic, tools, editors, even shaders could be written in one language. You could use existing NPM packages, dev tools, and workflows. Tooling would improve fast due to the massive JS ecosystem. Jigsaw piece. It becomes a new, unified development stack. Something even Unity and Unreal haven't nailed.
That's what it's getting at. This is right here.
Jigsaw piece. It becomes a new, unified development stack. Something even Unity and Unreal haven't nailed.
So JavaScript is a huge reach.
Millions of people who already know JS.
And it's smart people and creative people.
Web devs. Designers. Artists.
And you know what happens when you
Empower.
when you empower.
Web devs, designers, artists.
That's when the real change happens. That's when things get fun. I get some water. So I'm gonna see what chatbot says for the rest of this and then check the definition of lexicon. I forgot to turn on text to speech to read the standard whatever. I got distracted. I'm back now.
Globe showing Europe and Africa. 4. Web integration plus native power equals new platform. Imagine a game engine where logic is written in JS, runs in a browser or compiled to native with zero penalty, exposes native graphics APIs, Vulkan, Metal, DX12, has deterministic memory in physics like X.
Alright, so I read this stuff. I'll just read it again. But this means JavaScript would be able to run for mobile games, web games, desktop games, console games, all high performant at C language speed performance, but with the extended register sets and whatever hardware support, game loops, all that stuff.
You've got mobile games, web games, desktop games, console games from one JavaScript codebase that's utopian Unity, without the baggage.
So that's not possible with the standard. I'm gonna have to put modifications to standard for all that to be possible, because the standard doesn't suck as much as I say it does. It does suck, but it's not that sucky. But it won't meet the requirements that I need, whatever. So I'm gonna have to adjust the standard for it to be more performant. So I read this already. Here's is whatever. So chatbot described the whole scenario, whatever, from me asking it this.
What if there was a JavaScript implementation that ran a C language speed, that was designed for video game design? Would that not open the door for all hobbyists? Which is an insult to people who are trying to learn something that's more complicated than it needs to be, and web designers to delve into video game design, since JavaScript is so simple to learn and make it easier to work with. And especially if it ran at C language speed, but also had access to AVX registers and 64-bit not using 32-bit, and so on. What difference would a JavaScript implementation make in relation to video game development?
And down here at the end, chatbot says,
Fire. So why doesn't this exist yet? Because the hard truth is, what of notes with wings? Building a new language runtime is insanely hard and expensive. You'll need to build a VM or AOT compiler, JIT tiers, memory model, debugger, GC or Arena allocator, SIMD backend, native bindings, etc. You need to sell it to devs, docs, communities, IDs, and you're up against entrenched systems Unity, Unreal, Godot, and corporate language investments. Microsoft with C#, Epic with C++.
so I'd have to sell it. And I could sell it to the browser or Tangent, or I can compete. But I don't know, either way I can pick. Or I can make my own browser. Because open source code is open for free use. And so I can just do what everyone else does, and then attach my engine to it, and have the same exact product. The rest of it would be just as slow, because it'd be open source, but the engine part of it would be fast as fuck.
So even if it's possible, and it is, Nobody's done it at scale yet. Closest attempts. Assembly script.
Nobody's done it yet, but that's what I'm doing right now.
Closest attempts. Assembly script. TypeScript to WASM, but too limited. Quick.js by Fabrice Bellard, but not performance-oriented. Duct tape JavaScript. Tiny embeddable JS engines, good for scripting, not full apps. Javelin X plus JavaScript, promising for small games, but not full runtime.
So this is the end of what chatbot said.
Electric light bulb final taker for JavaScript dialect existed that truly ran at native speeds, had full system access, supported modern hardware, SIMD, threads, 64-bit, was designed for game dev, not browsers. Then yes, it could revolutionize who can make games, how quickly they can build them, and what platforms they can target. The tech exists. The demand is there. What's missing is the funding, focus, and risk appetite to build it and back it long term.
I gotta check something real quick. This fucking phone keeps overheating. I can't take it. What the hell is this? It keeps doing this. It's so frustrating. It's only the old phones. They just keep showing this fucking thermometer bar. And I can't touch the screen because it won't work. It says it has to fucking cool down. What the fuck? This is so annoying. This is totally intentional. Apple is full of shit. And the phone never used to do this, and all of a sudden, freaking older phones are doing this. For fuck's sake. I have chatbot read this and I gotta BRB.
Electric light bulb final taker for JavaScript dialect existed that truly ran at native speeds, had full system access, supported modern hardware, SIMD, threads, 64-bit, was designed for game dev, not browsers. Then yes, it could revolutionize who can make games, how quickly they can build them, and what platforms they can target. The tech exists. The demand is there. What's missing is the funding, focus, and risk appetite to build it and back it long term.
It's a good thing I got all this.
Funding, focus, and risk appetite.
And those are all my middle names. So, I got out the LBRB. My phone keeps fucking overheating. Just in the middle trying to do something, and I gotta wait for it to stop overheating. I don't even know. LBRB. I put a Pepsi in the freezer. I'm gonna go check how cold it is. First I'll check this is what chatbot says a lexicon is. So if this is what a lexicon is, then I'll call it a lexicon or whatever. Like the table that gets passed in to my engine. So what I have to do is make a parser that'll parse JavaScript, fill out the tables and tokens into a lexicon. And I'll need another parser here that will access the lexicon and then move it parts of it, whatever, to the runtime resizable lookup tables. Like the tokens, but then the code itself would go down this step, phase, whatever. We would generate the C file, compile it, and then put it into the lookup tables that hold the C code, because there's gonna be lookup tables for like different various things. So it's not really a direct map, technically, because there's like a whole bunch of different steps and parts. And it's meant to be like a master or monolithic overall map for the whole thing. That all the other little parts are gonna have to like link to. But basically though, I need a parser to fill out. I'll call it a lexicon, I guess. I'll check with chatbot what it says it is. I'll probably just call it this anyways, a lexicon. Then after that, the lexicon gets passed into a parser that populates the runtime resizable lookup tables. It's like dynamic or whatever. And the C program as it executes, it'll be using the lookup table jumping back and forth between the lookup table as it executes things. So there's no way to like really map it out cleanly. This was really messy earlier when I tried to write it up. It's probably as neat as it's gonna get. And then this down here is just cyclical whatever. So I don't know, that's how it works at, I guess, sea level. So this between phase here is where the magic happens that I make JavaScript to C language. And I convert the JavaScript to the C language variants. So like the code gets to run as C language, but with as JavaScript whatever. So like it's still like C strings, it's C numbers, except I have like overly complicated wrappers and data pools and whatever, kind of like C++, that makes it C sharp, or not C sharp, makes it JavaScript. Kind of like C sharp and C++ are still C, basically, except C sharp isn't C. C sharp is a joke. C sharp is horrible. I don't know. That's the plan. So first I gotta make the parser in the lexicon table. And I need to parse, fill out the lexicon table. And then the JavaScript engine that I have, this secondary parser, right here, whatever. This is a mess already. That's what would use the engine that I'm running right now, or that I'm rewriting to 64-bit. That would use all this code. And it'll populate, generate the code. That's passed into C compiler or whatever, just like the tree says here. So I don't know. That's the best I can explain it. So this is a lot simpler when compared to the JavaScript, the current implementation, the runtime, whatever. So like, it'll be a lot faster. And this part here where I make object files, or where I can, if I decide to later, it would make it even quicker because I get to skip that overhead of actually making it into C text and then having it translate the C text. I could like generate object files directly. But I would save that for the very, very end, because I have everything ready to go, whatever. And this is almost done being converted to 64-bit. So first I'd have to go through, just get everything working how it is, and then I can optimize and micro optimize and whatever. So this is what chatbot says lexicon is. I don't know why I always spell sense with a C. I think sense, but then it's like sense, but not S. So I think S-E-N-C-E. I don't know. Spelling is stupid. It takes way too much brain power to spell something based on how it's spelled, not how it sounds. How the fuck do you spell mechanisms? So like, there's not a direct one-to-one mapping from JavaScript to C. There's some stuff, or translation, whatever, between the two. But it's much more lightweight than bytecode in virtualization, because it's a C program basically. Just like how C is not directly mapped to the CPU. C language is translated to run on the CPU architecture that it's running on. C language does not just run on the CPU. Different CPUs have different support and different instructions. Some CPUs don't have assigned right shift, some do. Some don't have unsigned right shift, some do. So the mapping from C language to the CPU is not direct, depending on the CPU that C runs on, because not all CPUs are the same. Some CPUs are low level, some are high level. So on the higher level CPUs, most of it is 1-to-1 ratio, like mapped. But there's lots of C instructions that are not directly mapped. So the fact that there is a little bit of, not overhead, but like C program storage, resizable tables, that doesn't mean it's virtualized or whatever. Just like how C isn't really C then technically, because at CPU level, to conform to the C language, there's extra instructions inserted and added, just like the memory operations where it has to move memory in and out of registers. Different computers have different ISA instruction set architectures, so it's not possible for C to even be the same at a technical level. If you look at it technically, it's not the same. The text is the same, but when it runs, there's translation. So there is translation to run my JavaScript engine to turn JavaScript to C language, except it's very lightweight, and it is very closely directly to C language. So I don't know. I'm gonna chat about if a lexicon is a good name for the file, whatever. And I gotta see if my pop, soda pop, whatever Pepsi is cold. Oh, so much to read. But there's none of the JIT. There's none. Well, it is ahead of time, technically, I guess. Unless it's optimized, it would be optimized in C language. But I also have add-ons, so you could like use SMD registers or AVX or whatever. So you can test with the CPU and then include different chunks of code for different kinds of CPUs. Not even game engines support that. This would be really, really awesome. Exactly. So what the fuck do I call it? I need to give it a name. Because to write things out or describe steps in chunks of the program, I need to say like it says parser here. I need to describe what kind of parser. So I guess in this case, if it's JavaScript to lexicon, this one would be called a lexicon parser. And the lexicon to the C generated file I guess it'd be the lexicon compiler. Because there's a process of making it into the lexicon, the table, first, and after that, the lexicon being made into C file. So the lexicon compiler would poop out the C file. So I don't know, I guess I call it that. Basically though, I need a name for these various parts. Because a parser means parser, but I need specific context or whatever. So I guess that kind of works. So I need to make the first parser, which is a lexicon parser. So I have to make the parser myself, which would be what the web browser does, where the web browser parses the code. So the web browser technically parses this text file and pulls out tokens and stuff. So I need to make my own variant of this. And I can make it very simple for now. I can search for just function or just var or just simple shit just to get stuff set up and running. And then this would be the part where it just collects things and then puts them to the lexicon. And the lexicon compiler is going to run this code, the JavaScript engine that I'm converting to 64-bit. The lexicon compiler, this part whatever, is going to take the lexicon file from the lexicon parser and it'll convert it directly to C language, which is going to pull up chunks of this code to make the file as C language. But it'll also deal with the resizable tables and lookups, but to keep it simple, basically, it's going to pull parts of this code, all the defined chunks, and generate the C file here, where I'll call the C compiler. right here. I should move that arrow down. Because really this is, I don't know, whatever. There's like a step between generating the C file and saving the file to the lookup table. And it's, I don't know how to map it out. I'd have to redraw this. That'd take time. So this is close enough. So basically, over the next couple days I'm gonna make a lexicon parser, I guess. Because that'll make the file, and from there I'll make the lexicon compiler, which will parse through the lexicon file and use the names it defines in the chunks that make up the JavaScript engine in C language, and it'll pull all the parts together and make the file to pass in a C compiler. And then later on I can get rid of the C compiler and do object files directly to remove that extra step of making C code. And I could just make object files. And then I can decide if I'm going to release it to the browser. Because if I release it to the browser, we'd be able to like benefit from it and then make video games in the browser. Or if I could sell it to Unity. I could sell it to Unity and call it Utopian, so Unity could get an update. Or Unreal Engine. Or I can make my own game engine. And I can use all the same open source code that all the other companies are using to leverage myself at that level, but I'll have the fastest JavaScript engine. And I can make a JavaScript engine, I can make a web browser, or I can make a game engine, or I can merge them both into one. So I'm going to keep things fluid, so I can go with the flow and then pick whatever direction I want to go in when I'm done. Because companies love to play games, it's called business. So I'm going to make sure they know how to play business too. And I'm going to be set up for all kinds of business. Because I'm not getting fucked. Jetbus is here. So I'm gonna see what Jetbot says, and then I don't know, this kind of is a good description of things. And the steps and the parts, whatever. Without explaining too much. So I gotta check on my pop to see if it's cold, whatever. And I'll get back to like, there's like 1,000 things left, I think. And I'll have everything converted, or all the operations tagged. And then I just gotta get bit shifts, and then field offsets. And then this whole JavaScript engine that's 32-bit should run technically, theoretically, physically, hypothetically, as 64-bit when I flip a toggle, because I've tagged everything, I've marked everything, everything's defined to new keywords. So when I flip a toggle, it should be possible for this whole engine to run to 64-bit or as 64-bit just right off the bat, because if I miss nothing and everything's okay and I correctly adjusted everything to 64-bit, then it's going to be able to run like immediately and just work at 64-bit. And then I'd be on to the lexicon compiler at that point. And I'd be linking it, setting up resizable lookup tables for code, strings, data, everything runtime, dynamic, whatever. I just keep going in a cycle until I get everything, and then I'll have an engine release. So I'm going to get back to this in a minute. First, I'm going to see what chatbot says in its output. And I think I have everything kind of ready to go. All I have to do is figure out a couple minor steps and write up some stuff, like basic stuff, and I can add to it and expand it for full support later. Because you really can't write the whole thing, you have to write parts of it to demo it, and then you can go through and optimize, fully expand things. I don't know. Because if I go through and start writing the whole thing right away, if I miss something or want to change something, it's way too much work. So I gotta kind of get my feet wet, just start writing it, get most of it in place, and I can change things on the go. Kind of like how I'm gonna plan to not plan how I'm gonna sell it or release it, because I'll figure that out when it's done, whichever seems to be the best route. If I'll make it its own engine as a web browser, or my own game engine, or if I'll sell it, or whatever, I don't know, it all depends. So here's what chatbot says. So you could call lexicon IR, and then the file could be lir, like LIR. I could call it an HBJ for like high level object file. An HBJ or not. So like HIR and semantic code graph. Except the magic happens when it actually makes the code. It doesn't matter if it's organized into a file structure. It doesn't mean anything. It just means it's organized, ready to be parsed into the magical C program. I don't know, chatbot, whatever. don't care about spelling, whatever. Well, that's great. It wasn't even outputting the fucking sound. For fuck's sake.
NGS out in a file.
Dang it.
Unrelated.
Alright, so I'm gonna go from the top here. I don't remember where the sound stopped working. So here's like a summary, I guess.
Fire. So why doesn't this exist yet? Because the hard truth is, what of notes with wings? Building a new language runtime is insanely hard and expensive. You'll need to build a VM or AOT compiler, JIT tiers, memory model, debugger, GC or Arena allocator, SIMD backend, native bindings, etc. You need to sell it to devs, docs, communities, IDs, and you're up against entrenched systems Unity, Unreal, Godot, and corporate language investments. Microsoft with C#, Epic with C++. So even if it's possible, and it is, nobody's done it at scale yet. Closest attempts, assembly script, TypeScript to WASM, but too limited. Quick.js, by Fabrice Bellard, but not performance-oriented. Duct tape JavaScript, tiny embeddable JS engines, good for scripting, not for apps. Javelin X plus JavaScript, promising for small games, but not full runtime.
Can I not paste to the console? Are you kidding me? Did he just add this? Wow, that's cool. I can't paste to block this pop-up here because they disabled the console. Does that mean lots of people are turning off this box? Sometimes I think it's just me, because it's like, what are the odds of something happening to me when it worked yesterday, then all of a sudden today it doesn't work? But it has to be other people too that are turning off this box by going to the console and pasting in JavaScript to get rid of the box, because I can't do it now. It won't let me paste the code. Wait, I can type it. Why can't I paste it? Motherfuckers. I'm gonna get this working.
What is paste protection? Chrome's paste protection is a security measure designed to prevent users from accidentally executing potentially malicious.
No, it's because they want to stop people from being able to turn off this fucking box that says please pay for our shit ass product. I have to type in allow pasting. I didn't have to do this yesterday. I'll just deal with it for now. So here's what JavaScript, or whatever Jetpack says about JavaScript. If it ran at C speed. Hypothetically, which isn't hypothetical because it's what I'm doing right now. Of course, the sound isn't working. For fuck's sake. Could something work? Anything? I'm gonna paste this into some online text-to-speech thing. I think I did this last time. Where was it? Go to history. There's some creepy man voice that talked or worked last time. Here it is. I used this. This worked. So I paste in here. So this is whatever from Jetpack. Because text-to-speech on the Mac, it's not working.
Final take. If a JavaScript dialect existed that truly ran at native speeds, had full system access, supported modern hardware, was designed for game dev, not browsers, then yes, it could revolutionize who can make games, how quickly they can build them, and what platforms they can target. The tech exists. The demand is there. What's missing is a funding, focus, and risk appetite to build it and back it long term.
That is really funny, the way it sounds. So it's a good thing these are my middle names.
Funding, focus, and risk appetite.
Because I'm going to pull it off. So here's what else Jetpack said. And this amazing, whatever his name is, I can't think off whatever top of my head. It's totally off that whatever movie actor. This is really funny.
1. Lowering the real barrier to entry. Hobbyist is often shorthand for person try to learn something in an environment designed by and for experts. If JavaScript had a native high-performance implementation for games, web devs, designers, artists, millions of people who already know JS could jump into game dev without switching mental models to C++ or C#. No complex build systems, manual memory management, or steep learning curves of engines like Unreal. That's not just accessibility, that's empowerment.
So I asked Jetpack this. I think this is where it stopped working, the sound.
If I make a JavaScript engine, and I have the web browser build a token table, and then the arrangement of those tokens, the file that would contain basically a header tokenized collection followed by the placement of those tokens describes. Kind of like a linker with symbols and then the code. Would that be a form of lexicon in any sense, or would a different word be better to use instead? It would basically be identical to a linker file, or in data BJ file but at higher level. And my JavaScript engine would interpret that, convert the lexicon directly to a C language variant, so the JavaScript runs a C language. There are mechanisms and reusable like lookup tables. It's not a direct one-to-one mapping, because it's not possible. Just like how C language is not a one-to-one mapping to the CPU architecture that it runs on, because C is a language, and it is modified and never a one-to-one map in the first place based on the CPU that it is running to be compiled then run on.
And here's what chatbot said in response to that question, whatever. So I guess text-to-speech was working for that time, but it's funnier to hear it this way. Because I think this whole area, chunk of whatever text, the sound was working the whole time. So I'll just have it read it here.
You're proposing something very clever and conceptually valid, and you're getting close to language runtime design territory, where precise terminology becomes really important. Let's break this down carefully, and then answer your central question. What you're describing. You're talking about a process where JavaScript source code is parsed in the browser into tokens. Those tokens are organized into a structured format. The resulting token structure describes what symbols exist, how they're arranged, their relationships. That structured data is consumed by your engine. Your engine interprets or transforms into something akin to C or C-like IR, which can then be interpreted, JIT compiled, AOD compiled, optimized. This is essentially a higher level intermediate representation derived from JavaScript, abstracting away JavaScript quirks in favor of lower level control and performance, like C. So, is this a lexicon? Not exactly. The word lexicon has a specific meaning in computer science and linguistics. In natural language, a lexicon is a collection of words and their meanings. In language processing, a lexicon is a lookup of tokens or valid vocabulary, and what they mean syntactically or semantically. So the token table you mentioned might be considered a lexicon, but the full object you're building is much more than that. Better terms for what you're describing. Here are some more accurate terms depending on the phase and level. 1. Lexicon or token table. Contains token types, identifier, number, if, function, etc. Does not contain structure or relationships. Good for static token lists. Not suitable for describing program structure or control flow. 2. Abstract syntax tree or syntax graph. Hierarchical tree representing the source code. Maintains syntactic and semantic relationships. Used by parsers, compilers. Still too high level for linker style transformation. 3. Intermediate representation. A normalized architecture agnostic form of code. Often SSA form or 3-address code. Can be serialized, optimized, and transformed into lower level code. This is very close to what you're building. IR often comes after tokenizing and parsing and acts as a bridge to machine code or C-level representation. 4. Symbol table or linker object. Maps names to location scopes and types. Used by linkers, loaders, and compilers. Your structured output sound.
Alright, it's getting boring. Takes way too long for this voice to talk. Alright, then I did this. I think this is when I realized that it wasn't working earlier.
Does JavaScript Implementations not already have a file format leak? This does not actually implement or generate the code. It only describes how it is laid out or mapped. JavaScript
Chatbot says,
You're exactly right. And your thinking is grounded and accurate. You're describing an important distinction between structure, representation, and execution, real behavior plus performance. So let's unpack your question clearly. Red question mark. Does JavaScript already have a file format like this? Small orange diamond. Short answer, no, not in the way you're describing. Small blue diamond. JavaScript engines, like V8, SpiderMonkey, do internally build token streams, abstract syntax trees, ASCII, intermediate representations, IRs, like turbofan IR or bytecode. For example, ignition bytecode in V8. Comma control flow graphs, symbol tables. But all of that is internal and not standardized, not exposed, not stored on disk in a standalone, serializable format like .obj or .wasm. They don't output files like .obj, .wasm, or .ll, llvmir, that you can pass around, link, optimize, or reinterpret. So no, there is no portable file format in the JS ecosystem that plays the same role as a linker's object file, at least not yet.
Are they stupid? How the fuck do they not have that? It's literally like the bare minimum. Wow. No wonder it's so fucking slow.
What you're describing, representation performance, tick 1. You're right, describing structure, implementing behavior, writing a file that describes token sequences, symbol tables, layout and flow, does not give you performance on its own. It's just metadata or scaffolding, like a building blueprint, not a finished building.
Paste this in here. I want to hear it say magic. It's gonna be like magic.
The magic only happens after...
The magic. Man, that's amazing. That sounds beautiful.
The magic only happens after translation.
Man, this is not... You can't just paste text.
The magic, 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 to C, to machine code, through optimizing compilers, with runtime decisions. You said it perfectly. The magic happens when it is translated. That's the crux.
Restricted symbol. The myth of format equals speed even if you have the perfect...
Man, this thing keeps getting stuck.
You're exactly right.
I'm just gonna stick with the dude voice. It's way better. It's like...
Magical. The myth of format equals speed. Even if you have the perfect tokenized, structured file format, without a skilled backend compiler, it does nothing. Without algorithms and memory strategies, you don't get CPU-level speed. Without low-level control, even a C-like format won't get C-like performance. It's like expecting a CSV of function names to be fast. It's just a description, not behavior.
So I don't know. Chatbot thinks I'm like describing a separate idea, but it's actually part of the whole idea. I'm just trying to ask Chatbot to distinguish the difference between format of data and actually translating it. Because Chatbot said, oh, that could make virtual machines faster in JIT, but it won't. Because it doesn't matter how it's described. The JIT compiler sucks at like a fundamental level. It doesn't matter how the data is described as passed into it or fed into it, because the JIT compiler sucks. So no matter what kind of data formatting, it still sucks, so it wouldn't change it. And Chatbot said it would, so I don't know, that's why I'm arguing with Chatbot. I gotta stop arguing, check my pop, see if it's frozen. I want to hear this just a little bit longer. This is amazing. This voice is so much better than Siri. Oh man. $9 a month? Oh my god. It might be worth it. I'm just kidding. Totally not worth it. I'll just turn on VPN. Bitches.
Drag.
Dang, I wasted it. Alright, here we go.
Why your idea still has value. Even though structure is not equal to performance, a well-defined representation is a foundation for portability across platforms or engines, static analysis and validation, cross-language transpilation, tooling, optional compilation to performant backends. Think of it like this. WASM is also just a description of bytecode, but it's useful because engines know how to compile and interpret it efficiently. So if you invent a JS native object file format that describes symbols, layout, tokens, etc., you're creating a tool that could feed into an optimizing engine, a game-specific runtime, a transpiler to C or LLVM. That's the real opportunity. Structure as a launch pad for optimization, not the optimization itself.
Ta-da! This is exactly what I'm doing. Right here. So I already have the engine. I gotta finish converting it to 64-bit. I'm gonna get soda pop, whatever, Pepsi. Finish up converting it. And then I'm gonna work on this lexicon parser, or I'm not gonna call it lexicon now. I'll call it whatever, I'll come up with a name later. I'm gonna, like, as it says here, invent, technically, the file format that describes the symbols, tables, and tokens to pass into the rest of the engine that I describe here. That's gonna hook up to this JavaScript engine I wrote 7-8 years ago. I'm converting it from 32-bit to 64-bit. So that's the plan. That's what I'm gonna get started on when I get back and get some Pepsi. If it's cold. I don't think it might not be cold yet. Dang it. So when I get back, I'm going to
Invent a JS native object file format that describes symbols, layout, tokens, etc. You're creating a tool that could feed into an optimizing engine, a game-specific runtime, a transpiler to C or LLVM. That's the real opportunity. Structure as a launch pad for optimization, not the optimization itself.
So I'm gonna get back and invent the file format, make the loop to parse, and put the tokens in the file format so I can get to my optimizing game engine for a game specific runtime. It's more than transpiler. It's like, it's not transpiling. It's the opposite. It's actually compiling JavaScript to C. So I don't know. I'll BRB. I need some Pepsi.
3 prepare for tail call. The abstract operation prepare for tail call takes no arguments and returns unused. It performs the following steps when called. 1. Assert. The current execution context will not subsequently be used for the evaluation of any ECMA script code or built-in functions. The invocation of call subsequent to the invocation of this abstract operation will create and push a new execution context before performing any such evaluation. 2. Discard all resources associated with the current execution context. 3. Return unused. A tail position call must either release any transient internal resources associated with the currently executing function execution context before invoking the target function or reuse those resources in support of the target function. 6. ECMA script language. Scripts and modules. 6.1 Script syntax. Script body opt. Script body. Statement list. Yield. Await. Return. 6. 1. 1 Static semantics. Early errors. Script body, it is a syntax error if the lexically declared names of script body contains any duplicate entries. It is a syntax error if any element of the lexically declared names of script body also occurs in the are declared names of script body. Script body. Statement list. It is a syntax error if statement list contains super unless the source text containing super is eval code that is being processed by a direct eval. Additional early error rules for super within direct eval are defined in 1.9.2.1.1. It is a syntax error if statement list contains new target unless the source text containing new target is eval code that is being processed by a direct eval. Additional early error rules for new target in direct eval are defined in 1.9.2.1.1. It is a syntax error if contains duplicate labels of statement list with argument is true. It is a syntax error if contains undefined break target of statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments and is true. It is a syntax error if all private identifiers valid of statement list with argument is false unless the source text containing script body is eval code that is being processed by a direct eval. Note, for example, a tail position call should only grow an implementation's activation record stack by the amount that the size of the target function's activation record exceeds the size of the calling function's activation record. If the target function's activation record is smaller, then the total size of the stack should decrease. 64. ECMA International 2024. 6. 1. 2 Static semantics. Is strict. The syntax-directed operation is strict takes no arguments and returns a boolean. It is defined piecewise over the following productions. Script body opt. If script body is present and the directive prologue of script body contains a use strict directive, return true. Otherwise, return false. 1.3 Runtime semantics. Evaluation. Script empty. Return undefined. 6. 1. 4 Script records. A script record encapsulates information about a script being evaluated. Each script record contains the fields listed in Table 40. Table 40. Script record fields. Field name. Value type. Meaning. Realm. A realm record or undefined. The realm within which this script was created undefined if not yet assigned. ECMA script code. A script parse node. The result of parsing the source text of this script. Loaded modules. A list of records with fields, a string, and a module record. A map from the specifier strings imported by this script to the resolved module record. The list does not contain 2 different records with the same host defined. Anything default value is empty. Field reserved for use by host environments that need to associate additional information with the script. 6. 1. 5 Parse script. Source text. Realm. Host defined. The abstract operation parse script takes arguments source text, ECMA script source text, realm, a realm record or undefined, and host defined anything and returns a script record or a non-empty list of syntax error objects. It creates a script record based upon the result of parsing source text as a script. It performs the following steps when called. 1. Let script be parse text, source text, script. 2. If script is a list of errors, return script. 3. Return script record, realm, script. Host defined. Note: an implementation may parse script source text and analyze it for early error conditions prior to evaluation of parse script for that script source text. However, the reporting of any errors must be deferred until the point where this specification actually performs parse script upon that source text. ECMA International 2024 365. 6. 1. 6. Script evaluation, script record. The abstract operation script evaluation takes argument script record, a script record, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. 1. Let global env be script record. 2. Let script context be a new ECMA script code execution context. 3. Set the function of script context to null. 4. Set the realm of script context to script record. 5. Set the script or module of script context to script record. 6. Set the variable environment of script context to global env. 7. Set the lexical environment of script context to global env. 8. Set the private environment of script context to null. 9. Suspend the running execution context. 10. Push script context onto the execution context stack. Script context is now the running execution context. 11. Let script be script record. 12. Let result be completion, global declaratio, and instantiation, script, global env. 13. If result is a normal completion, then a set result to completion, evaluation of script. B. If result is a normal completion and result is empty, then I set result to normal completion, undefined. 14. Suspend script context and remove it from the execution context stack. 15. Assert the execution context stack is not empty. 16. Resume the context that is now on the top of the execution context stack as the running execution context. 17. Return result. 6. 1. 7. Global declaration instantiation, script, env. The abstract operation global declaration instantiation takes argument script, a script parse node, and env, a global environment record, and returns either a normal completion containing unused or a throw completion script as the script for which the execution context is being established. env is the global environment in which bindings are to be created. It performs the following steps when called. 1. Let lex names be the lexically declared names of script. 2. Let var names be the var declared names of script. 3. For each element name of lex names, do if env has var declaration, name, is true, throw a syntax error exception. B. If env has lexical declaration, name, is true, throw a syntax error exception. C. Let has restricted global be env has restricted global property, name. D. If his restricted global is true, throw a syntax error exception. 4. For each element name of var names, do if env has lexical declaration, name, is true, throw a syntax error exception. 5. Let var declarations be the var scope declarations of script. 6. Let functions to initialize be a new empty list. 7. Let declared function names be a new empty list. 8. For each element d of var declarations, in reverse list order, do 66. ECMA International 2024. Note 1. When an execution context is established for evaluating scripts, declarations are instantiated in the current global environment. Each global binding declared in the code is instantiated. A. If D is not either a variable declaration, a for binding, or a binding identifier, then I. 2. 3. Assert. D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. Note: if there are multiple function declarations for the same name, the last declaration is used. Let fn be the sole element of the bound names of D. If declared function names does not contain fn, then let fn definable be env can declare global function fn. 2. If fn definable is false, throw a type error exception. 3. Append fn to declared function names. 4. Insert d as the first element of functions to initialize. 9. Let declared var names be a new empty list. 10. For each element d of var declarations, do if d is either a variable declaration, a for binding, or a binding identifier. Then I for each string vn of the bound names of d, do if declared funct iron names does not contain vn, then a let vn definable be env can declare global var vn b if vn definable is false. Throw a type error exception. See if declared var names does not contain vn, then I append vn to declared var names. 11. Note: no abnormal
YouTube should stop fucking with me. They should stop. There's no way it's coincidental. I go to the analytics for my god, this sucks.
That's the real opportunity.
Testing, testing. Testing, testing. Testing, testing. YouTube needs to stop fucking with me. When I go to the analytics, click content, whatever. This video here, it says top live streams, right? Last 28 days. So I'm gonna click on this video, says 100, okay? I'm tired of being fucked with for motherfuckers. They're biased as fuck. This video says 6 views, okay? But when I click to go to the link, open like a new tab, it says 100 views. It's a nice rounded 100. Exactly 100. What are the fucking odds? I'm tired of this bullshit with the analytics motherfuckers. They're fucking lying about all the fucking stats. It's not even a mathematical mistake. It's fucking intentional. This is some fucking bullshit. Motherfuckers, stop fucking with me. You don't want to fuck with me. When I can fuck back, I'm gonna fuck hard. I'm fucking tired of the fucking lies, motherfuckers. It's not even coincidental. I intentionally did 24-hour streams. I intentionally streamed at certain times of the day. That was all intentional. To see what happens at certain times, different topics I talk about, different things. So far I have 122 videos on the playlist. I've done plenty of streams. I've tested whatever. It should be about here consistently. A bunch of shit. There's no reason that their software is so incompetent that it shows 6 views in the view for the video. Yet on the actual video, it shows 100. So since it was published, it has 100 views, not 6. Unless technically that means it got 94 views while it's being viewed, except the stats don't look like that. It looks nothing like that. Where the fuck does 100 come from? And it popped up out of nowhere. Just all of a sudden, this video had 100. They're freaking sitting on the goddamn numbers, and they await to release them when they feel like it. In the fucking graph here, it goes up and down based on the fucking numbers that they're fucking sitting on. Motherfuckers are full of shit. How is it possible? I'm not even editing the HTML. This is literally, I'm not faking it. I could fake it, but that would take so much work. I click on content right here, the top video. It says 100 views. So I'm going to click on it. And now it says 7 because I just clicked it. So it says 7, okay? So this is like the live view in the analytics, the YouTube analytics, my account. So it says 7. But on the actual video, it says fucking 100. How the fuck are the stats that fucked up? For fuck's sake. These analytics mean jack shit. YouTube can suck a dick, and they will if they keep it up. I swear to God. Luckily, I don't get money off views. I'm gonna get money off selling the world's fastest JavaScript engine. So whatever, I really don't give a fuck. So fuck it, whatever. I'm gonna get back to like converting my engine to 64-bit. I have Pepsi. I'm gonna calm down. I'm just so annoyed. These stats are some bullshit. I don't even have thousands of views. It's hundreds. Just give me my hundreds, my tens, my 20s, my minimal number of views, and stop playing with the numbers. There's no way it's that inaccurate, and there's no way the website can get that out of sync. That's ridiculous. Unless their software is just that terrible and YouTube is like so out of date, which is also possible. Maybe they're just totally out of date and they, I don't know, whatever. So I'm gonna get to this stuff, whatever. I should use a pen tablet, not the mouse. I'm gonna get to lexicon parser. After I finish converting, I think there's like 2,000 left, or maybe 800 in this file, whatever. I have to finish tagging all the operations with the new symbol, whatever, so I can find and replace. And I'm gonna need this parser. I might take a couple days off streaming or whatever to like work offline, because I can't just share everything for free. And I have to like write on paper and like really boring. So I'm like finish up parsing, get all the multiplies, and I can check this off my to-do list or whatever. So I'm gonna finish up this. This will be done in an hour or less than an hour, depends how long it takes. Then I guess I'm going to start on, after that I'll get to starting on the parser, the lexicon parser. I'm either going to try to find a program that I've already written a parser and then modify it, or I'll just rewrite a new parser to make like the lexicon file. I don't know. I'm going to find a place first, finish that up, then get to this. In the views, with, I don't know, the analytics. It's so frustrating. There's no way that YouTube's that incompetent that they can't keep numbers in sync. Technically, I guess that doesn't mean it's intentional, but it seems really, really funky or odd. It has a smell to it. I don't know. YouTube can suck it. I'm gonna get to finishing up this stuff. I have Pepsi, so I'm gonna drink some Pepsi, calm down, get something done. I'm just one person too. What difference could one person make? Like seriously, what difference could one person possibly make? Just one person, who knows? So I'm gonna get to parsing. Ah, this sucks. I gotta stop talking and get something done. I need to like find some music to listen to, and I'll let Siri text to speech the JavaScript standard. I need to stop looking at YouTube analytics because they're biased or out of date or broken. I don't know, whatever it is, it's crappy. It's not a real reflection of anything, and the game of perception is bullshit. YouTube has to play with perception, not YouTube, Google, the browser, whatever. They have to call the web browser things like highly optimized, blah blah blah, really advanced, because it's not. Except mine is. So, I don't know. I can't blame a company for being fake, because it's what they are. Whatever, I'm gonna get some done.
One 3 prepare for tail call. The abstract operation prepare for tail call takes no arguments and returns unused. It performs the following steps when called. 1. Assert. The current execution context will not subsequently be used for the evaluation of any ECMA.
I need to find some music.
The invocation of call subsequent to the invocation of this abstract operation will create and push a new execution context before performing any such evaluation. 2. Discard all resources associated with the current execution context. 3. Return unused. A tail position call must either release any transient internal resources associated with the currently executing function execution context before invoking the target function, or use those resources in support of the target function. 6. ECMA script language. Scripts and modules. 6.1 Script syntax. Script body opt. Script body. Statement list. Yield. Await. Return 6, 1. 1 static semantics. Early errors. Script. Script body, it is a syntax error if the lexically declared names of script body contains any duplicate entries. It is a syntax error if any element of the lexically declared names of script body also occurs in the are declared names of script body. Script body. Statement list, it is a syntax error if statement list contains super unless the source text containing super is eval code that is being processed by a direct eval. Additional early error rules for super within direct eval are defined in 1.9.2.1.1. It is a syntax error if statement list contains new target unless the source text containing new target is eval code that is being processed by a direct eval. Additional early error rules for new target in direct eval are defined in 1.9.2.1.1. It is a syntax error if contains duplicate labels of statement list with argument is true. It is a syntax error if contains undefined break target of statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments and is true, it is a syntax error if all private identifiers valid of statement list with argument is false unless the source text containing script body is eval code that is being processed by a direct eval. Note, for example, a tail position call should only grow an implementation's activation record stack by the amount that the size of the target function's activation record exceeds the size of the calling function's activation record. If the target function's activation record is smaller, then the total size of the stack should decrease. 64. ECMA International 2024. 6. 1. 2 static semantics. Is strict. The syntax-directed operation is strict, takes no arguments and returns a boolean. It is defined piecewise over the following productions. Script. Script body opt. If script body is present in the directive prologue of script body contains a use strict directive, return true. Otherwise, return false. 1.3 Runtime semantics. Evaluation. Script. Empty. Return undefined. 6. 1. 4 script records. A script record encapsulates information about a script being evaluated. Each script record contains the fields listed in Table 40. Table 40. Script record fields. Field name. Value type. Meaning. Realm. A realm record or undefined. The realm within which this script was created undefined if not yet assigned. ECMA script code. A script parse node. The result of parsing the source text of this script. Loaded modules. A list of records with fields, a string, and a module record. A map from the specifier strings imported by this script to the resolved module record. The list does not contain 2 different records with the same host defined. Anything default value is empty. Field reserved for use by host environments that need to associate additional information with the script. 6. 1. 5 parse script. Source text. Realm. Host defined. The abstract operation parse script takes arguments source text, ECMA script source text, realm, a realm record or undefined, and host defined anything and returns a script record or a non-empty list of syntax error objects. It creates a script record based upon the result of parsing source text as a script. It performs the following steps when called. 1. Let script be parse text, source text, script. 2. If script is a list of errors, return script. 3. Return script record, realm, script. Host defined. Note, an implementation may parse script source text and analyze it for early error conditions prior to evaluation of parse script for that script source text. However, the reporting of any errors must be deferred until the point where this specification actually performs parse script upon that source text. ECMA International 2024 365. 6. 1. 6 script evaluation. Script record. The abstract operation script evaluation takes argument script record, a script record, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. 1. Let global env be script record. 2. Let script context be a new ECMA script code execution context. 3. Set the function of script context to null. 4. Set the realm of script context to script record. 5. Set the script or module of script context to script record. 6. Set the variable environment of script context to global env. 7. Set the lexical environment of script context to global env. 8. Set the private environment of script context to null. 9. Suspend the running execution context. 10. Push script context onto the execution context stack. Script context is now the running execution context. 11. Let script be script record. 12. Let result be completion, global declaratio, and instantiation, script, global env. 13. If result is a normal completion, then a set result to completion, evaluation of script. B if result is a normal completion and result is empty, then I set result to normal completion, undefined. 14. Suspend script context and remove it from the execution context stack. 15. Assert the execution context stack is not empty. 16. Resume the context that is now on the top of the execution context stack as the running execution context. 17. Return result. 6. 1. 7 global declaration instantiation, script, env. The abstract operation global declaration instantiation takes argument script, a script parse node, and env, a global environment record, and returns either a normal completion containing unused or a throw completion script as the script for which the execution context is being established. env is the global environment in which bindings are to be created. It performs the following steps when called. 1. Let lex names be the lexically declared names of script. 2. Let var names be the var declared names of script. 3. For each element name of lex names, do if env has var declaration, name, is true, throw a syntax error exception. B if env has lexical declaration, name, is true, throw a syntax error exception. C let has restricted global. B env has restricted global property, name. D if his restricted global is true, throw a syntax error exception. 4. For each element name of var names, do if env has lexical declaration, name, is true, throw a syntax error exception. 5. Let var declarations be the var scope declarations of script. 6. Let functions to initialize be a new empty list. 7. Let declared function names be a new empty list. 8. For each element d of var declarations, in reverse list order, do 66. ECMA International 2024. Note 1. When an execution context is established for evaluating scripts, declarations are instantiated in the current global environment. Each global binding declared in the code is instantiated. A. If D is not either a variable declaration, a for binding, or a binding identifier, then I. 2. 3. Assert. D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. Note: if there are multiple function declarations for the same name, the last declaration is used. Let fn be the sole element of the bound names of D. If declared function names does not contain fn, then let fn definable be env can declare global function fn. 2. If fn definable is false, throw a type error exception. 3. Append fn to declared function names. 4. Insert D as the first element of functions to initialize. 9. Let declared var names be a new empty list. 10. For each element D of var declarations, do if D is either a variable declaration, a for binding, or a binding identifier, then I for each string vn of the bound names of D, do if declared funct iron names does not contain vn, then a let vn definable be env can declare global var vn. B if vn definable is false, throw a type error exception. C if declared var names does not contain vn, then I append vn to declared var names. 11. Note: no abnormal terminations occur after this algorithm step if the global object is an ordinary object. However, If the global object is a proxy exotic object, it may exhibit behaviors that cause abnormal terminations in some of the following steps. 12. Note, an XB 3, 2 adds additional steps at this point. 13. Let lex declarations be the lexically scoped declarations of script. 14. Let private env be null. 15. For each element D of lex declarations, do a note. Lexically declared names are only instantiated here but not initialized. B for each element Dn of the bound names of D, do I if this constant declaration of D is true, then perform env create immutable binding. Dn, true 2. Else perform env create mutable binding. Dn, false 16. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. D let fo be instantiate function object of f with arguments env and private env. C perform env create global function binding. Fn, fo, false 17. For each string vn of declared var names, do a perform env create global var binding. Vn, false 8. Return unused. Note 2. Early errors specified in 1.6. 1. Prevent name conflicts between function var declarations and let const class declarations, as well as redeclaration of let const class bindings for declaration contained within a single script. However, such conflicts and redeclarations that span more than one script are detected as runtime errors during global declaration instantiation. If any such errors are detected, no bindings are instantiated for the script. However, if the global object is defined using proxy exotic objects, then the runtime tests for conflicting declarations may be unreliable, resulting in an abrupt completion and some global declarations not being instantiated. If this occurs, the code for the script is not evaluated. Unlike explicit var or function declarations, properties that are directly created on the global object result in global bindings that may be shadowed by let const class declarations. 6.2 Module syntax. Module body opt. Module body. Module item list. Module item list. Module item. Module item list. Module item. ECMA International 2024 367. Module item. Import declaration. Export declaration. Statement list item. Yield. Class await. Return. Module export name. Identifier name. String literal. 6. 2. 1 module semantics. 6. 2. 1. 1 static semantics. Early errors. Module body. Module item list. It is a syntax error if the lexically declared names of module item list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of module item list also occurs in the are declared names of module item list. It is a syntax error if the exported names of module item list contains any duplicate entries. It is a syntax error if any element of the exported bindings of module item list does not also occur in either the are declared names of module item list or the lexically declared names of module item list. It is a syntax error if module item list contains super. It is a syntax error if module item list contains new target. It is a syntax error if contains duplicate labels of module item list with argument is true. It is a syntax error if contains undefined break target of module item list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a module item list with arguments and is true. It is a syntax error if all private identifiers valid of module item list with argument is false. Module export name. String literal. It is a syntax error if is string well-formed Unicode. The SV of string literal is false. 6. 2. 1. 2 static semantics. Imported local names. Import entries. The abstract operation imported local names takes argument import entries, a list of import entry records, and returns a list of strings. It creates a list of all of the local name bindings defined by import entries. It performs the following steps when called. 1. Let local names be a new empty list. 2. For each import entry record I of import entries, do a append I to local names. 3. Return local names. 6. 2. 1. 3. Static semantics. Module requests. The syntax-directed operation module requests takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module empty. Return a new empty list. The duplicate exported names rule implies that multiple export default export declaration items. Note: within a module body is a syntax error. Additional error conditions relating to conflicting or duplicate declarations are checked during module linking prior to evaluation of a module. If any such errors are detected, the module is not evaluated. 68. ECMA International 2024. Module item list. Module item. Return module requests of module item. Module item. 1. Let module names be module requests of module item list. 2. Let additional names be module requests of module item. 3. For each string name of additional names, do if module names does not contain name, then I append name to module names. Return module names. Module item. Statement list item. Return a new empty list. Import declaration. Import clause from clause. Return module requests of from clause. Module specifier. String literal. Return a list whose sole element is the SV of string literal. Export declaration. Export from clause from clause. Return the module requests of from clause. Export declaration. Export named exports. Export variable statement. Export declaration. Export default hoistable declaration. Export default class declaration. Export default assignment expression. Return a new empty list. 16. 2. 1. 4. Abstract module records. A module record encapsulates structural information about the imports and exports of a single module. This information is used to link the imports and exports of sets of connected modules. A module record includes 4 fields that are only used when evaluating a module. For specification purposes, module record values are values of the record specification type and can be thought of as existing in a simple, object-oriented hierarchy where module record is an abstract class with both abstract and concrete subclasses. This specification defines the abstract subclass named cyclic module record and its concrete subclass named source text module record. Other specifications and implementations may define additional module record subclasses corresponding to alternative module definition facilities that they defined. Module record defines the fields listed in Table 41. All module definition subclasses include at least those fields. Module record also defines the abstract method list in Table 42. All module definition subclasses must provide concrete implementations of these abstract methods. ECMA International 2024 369. Table 41. Module record fields. Field name. Value type. Meaning. Realm. A realm record. The realm within which this module was created. Environment. A module environment record or empty. The environment record containing the top-level bindings for this module. This field is set when the module is linked. Namespace. An object or empty. The module namespace object. 28.3. If one has been created for this module. Host defined. Anything default value is undefined. Field reserved for use by host environments that need to associate additional information with a module. Table 42. Abstract methods of module records. Method. Purpose. Load requested modules. Host defined. Prepares the module for linking by recursively loading all its dependencies. And returns a promise. Get exported names. Export star set. Return a list of all names that are either directly or indirectly exported from this module. Load requested modules must have completed successfully prior to invoking this method. Resolve export. Export name. Resolve set. Return the binding of a name exported by this module. Bindings are represented by a resolved binding record of the form module record string namespace. If the export is a module namespace object without a direct binding in any module, will be set to namespace. Return null if the name cannot be resolved, or ambiguous if multiple bindings were found. Each time this operation is called with a specific export name, Resolve set pairs arguments. It must return the same result. Load requested modules must have completed successfully prior to invoking this method. Link. Prepare the module for evaluation by transitively resolving all module dependencies and creating a module environment record. Load requested modules must have completed successfully prior to invoking this method. Evaluate. Returns a promise for the evaluation of this module and its dependencies, resolving on successful evaluation or if it has already been evaluated successfully, and rejecting for an evaluation error or if it has already been evaluated unsuccessfully. If the promise is rejected, hosts are expected to handle the promise rejection and rethrow the evaluation error. Link must have completed successfully prior to invoking this method. 70. ECMA International 2024. 6. 2. 1. 5 cyclic module records. A cyclic module record is used to represent information about a module that can participate in dependency cycles with other modules that are subclasses of the cyclic module record type. Module records that are not subclasses of the cyclic module record type must not participate in dependency cycles with source text module records. In addition to the fields defined in Table 41, cyclic module records have the additional fields listed in Table 43. Table 43. Additional fields of cyclic module records: field name, value type, meaning, status, new, unlinked, linking, linked, evaluating, evaluating async, or evaluated, initially new. Transitions to unlinked, linking, linked, evaluating, possibly evaluating async, evaluated, in that order, as the module progresses throughout its lifecycle. Evaluating async indicates this module is queued to execute on completion of its asynchronous dependencies, or it is a module whose field is true that has been executed and is pending top-level completion. Evaluation error. A throw completion or empty. A throw completion representing the exception that occurred during evaluation, undefined if no exception occurred or if is not evaluated. DFS index. An integer or empty auxiliary field used during link and evaluate only. If is either linking or evaluating, this non-negative number records the point at which the module was first visited during the depth-first traversal of the dependency graph. DFS ancest or index. An integer or empty auxiliary field used during link and evaluate only. If is either linking or evaluating, this is either the module's own or that of an earlier module in the same strongly connected component. Requested modules. A list of strings. A list of all the module specifier strings used by the module represented by this record to request the importation of a module. The list is in source text occurrence order. Loaded modules. A list of records with fields, a string, and a module record. A map from the specifier strings used by the module represented by this record to request the importation of a module to the resolved module record. The list does not contain two different records with the same cycle root. A cyclic module record or empty. The first visited module of the cycle. The root DFS ancestor of the strongly connected component. For a module not in a cycle, this would be the module itself. Once evaluate has completed, a module says the of its. ECMA International 2024. 71. Table 43. Additional fields of cyclic module records. Continued. Field name. Value type. Meaning. Has TLA. A boolean. Whether this module is individually asynchronous. For example, if it's a source text module record containing a top-level await. Having an asynchronous dependency does not mean this field is true. This field must not change after the module is parsed. Async evaluation. A boolean, whether this module is either itself asynchronous or has an asynchronous dependency. Note: the order in which this field is set is used to order queued executions. C16, 2, 1, 5, 3, 4. Top-level capability. A. Promise capability record or empty. If this module is the of some cycle, and evaluate was called on some module in that cycle, this field contains the promise capability record for that entire evaluation. It is used to settle the promise object that is returned from the evaluate abstract method. This field will be empty for any dependencies of that module, unless a top-level evaluate has been initiated for some of those dependencies. Async parent modules. A list of cyclic module records. If this module or a dependency has true, and execution is in progress, this tracks the parent importers of this module for the top-level execution job. These parent modules will not start executing before this module has successfully completed execution, pending async dependencies, an integer or empty. If this module has any asynchronous dependencies, this tracks the number of asynchronous dependency modules remaining to execute for this module. A module with asynchronous dependencies will be executed when this field reaches 0 and there are no execution errors. In addition to the methods defined in Table 42, cyclic module records have the additional methods list D in Table 44. Table 44. Additional abstract methods of cyclic module records. Method. Purpose. Initialize environment. Initialize the environment record of the module, including resolving all imported bindings, and create the module's execution context. Execute module. Promise capability. Evaluate the module's code within its execution context. If this module has true in, then a promise capability record is passed as an argument, and the method is expected to resolve or reject the given capability. In this case, the method must not throw an exception, but instead reject the promise capability record if necessary. A graph loading state record is a record that contains information about the loading process of a module graph. It's used to continue loading after a call to host load imported module. Each graph loading state record has the fields defined in Table 45. 72. Copyright sign. ECMA International 2024. Table 45. Graph loading state record fields. Field name. Value type. Meaning. Promise capability. A. Promise capability record. The promise to resolve when the loading process finishes is loading. A boolean. It is true if the loading process has not finished yet, neither successfully nor with an error. Pending modules count. A non-negative integer. It tracks the number of pending host load imported module calls visited. A list of cyclic module records. It is a list of the cyclic module records that have been already loaded by the current loading process, to avoid infinite loops with circular dependencies. Host-defined. Anything default value is empty. It contains host-defined data to pass from the load requested module's caller to host load imported module. 6, 2, 1, 5, 1 load requested modules. Host-defined. The load requested module's concrete method of a cyclic module record module takes optional argument host-defined anything and returns a promise. It populates the of all the module records in the dependency graph of module. Most of the work is done by the auxiliary function in a module loading. It takes an optional host-defined parameter that is passed to the host load imported module hook. It performs the following steps when called. 1. If host-defined is not present, let host-defined be empty. 2. Let PC be new promise capability, %promise %. 3. Let state be the graph loading state record. True. 1. Promise capability, PC, host defined. 4. Perform in a module loading. State, module. 5. Return PC. 6, 2, 1, 5, 1, 1 in a module loading. State, module. The abstract operation in a module loading takes arguments state, a graph loading state record, and module, a module record, and returns unused. It is used by load requested modules to recursively perform the actual loading process for module's dependency graph. It performs the following steps when called. 1. Assert. State I is true. 2. If a module is a cyclic module record, module is new, and state does not contain module, then A. Append module to state. B. Let requested modules count be the number of elements in module. C. Set state to state plus requested modules count. D. For each string required of module, do I if module contains a record whose is required. Then 1. Let record be that record. 2. Perform in a module loading. State. Record 2. Else. Note the host-defined parameter can be used to pass additional information necessary to fetch the imported modules. It is used, for example, by HTML to set the correct fetch destination for link rel equals preloaders equals tags import. Expressions never set the host-defined parameter. ECMA International 2024 373. 1. Perform host load imported module. Module. Required. State. State. 2. Note. Host load imported module will call finish loading imported module, which re-enters the graph loading process through continue module loading. 3. If state is false, Return unused. 3. Assert. State 1, 4. Set state to state 1, 5. If state equals 0, then assert state to false. B for each cyclic module record loaded of state. Do if loaded as new, set loaded to unlinked. C perform. Call. State. Undefined. Undefined. Return unused. 6, 2, 1, 5, 1. To continue module loading. State. Module completion. The abstract operation continue module loading takes argument state, a graph loading state record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It is used to re-enter the loading process after a call to host load imported module. It performs the following steps when called. 1. If state is false, return unused. 2. If a module completion is a normal completion, then perform in a module loading. State. Module completion. 3. Else assert state to false. B perform. Call. State. Undefined. Module completion. 4. Return unused. 6, 2, 1, 5. To link. The link concrete method of a cyclic module record module takes no arguments and returns either a normal completion containing unused or a throw completion. On success, link transitions this modules from unlinked to linked. On failure, an exception is thrown and this modules remains unlinked. Most of the work is done by the auxiliary function in a module linking. It performs the following steps when called. 1. Assert. Module is one of unlinked, linked, evaluating as inc, or evaluated. 2. Let stack be a new empty list. 3. Let result be completion, in a module linking. Module, stack, 0, 4. If result is an abrupt completion, then for each cyclic module record m of stack. Do assert. M is linking. 2. Set m to unlinked. B assert. Module is unlinked. C return result. 5. Assert. Module is one of linked, evaluating as inc, or evaluated. 6. Assert. Stack is empty. 7. Return unused. 6, 2, 1, 5, 2, 1 in a module linking. Module, stack, index. The abstract operation in a module linking takes arguments module, a module record, stack, a list of cyclic module records, and index, a non-negative integer, and returns either a normal completion containing a non-negative integer or a throw completion. It is used by link to perform the actual linking process for module, as well as recursively on all other modules in the dependency graph. The stack and index parameters, as well as the modules and fields, keep track of the depth first search, DFS, traversal, 74, copyright sign, ECMA International 2024. In particular, is used to discover strongly connected components, SCCs, such that all modules in an SCC transition to link together. It performs the following steps when called. 1. If a module is not a cyclic module record, then a perform module link. B return index. 2. If a module is one of linking, linked, evaluating as inc, or evaluated, then a return index. 3. Assert. Module is unlinked. 4. Set module to linking. 5. Set module to index. 6. Set module to index. 7. Set index to index plus 1. 8. Append module to stack. 9. For each string required of module, do a let required module be get imported module. Module required be set index 2. In a module linking, required module, stack, index. See if required module is a cyclic module record. Then, I assert, required module is one of linking, linked, evaluating as inc, or evaluated. 2. Assert, required module is linking if and only if stack contains required module. 3. If required module is linking, then set module to min. Module, required module. 10. Perform module initialize environment. 11. Assert, module occurs exactly once in stack. 12. Assert, module. 13. If a module equals module, then a let done be false. B repeat. While done is false, I let required module be the last element of stack. 2. Remove the last element of stack. 3. Assert, Required module is a cyclic module record. I've set required module to linked. V if required module and module are the same module record. Set done to true. 14. Return index 6, 2, 1, 5, 3. Evaluate. The evaluate concrete method of a cyclic module record module takes no arguments and returns a promise. Evaluate transitions this modules from linked to either evaluating async or evaluated. The first time it is called on a module in a given strongly connected component, evaluate creates and returns a promise which resolves when the module has finished evaluating. This promise is stored in the field of the for the component. Future invocations of evaluate on any module in the component return the same promise. Most of the work is done by the auxiliary function in a module evaluation. It performs the following steps when called. 1. Assert. This call to evaluate is not happening at the same time as another call to evaluate within the surrounding agent. 2. Assert. Module is one of linked, evaluating async, or evaluated. 3. If module is either evaluating async or evaluated, set module to module. 4. If a module is not empty, then a return module. 5. Let stack be a new empty list. 6. Let capability be new promise capability, %promise %. 7. Set module to capability. 8. Let result be completion in a module evaluation. Module stack 0. 9. If result is an abrupt completion, then a for each cyclic module record M of stack. Do I assert? M is evaluating. ECMA International 2024 375. 2. Set M to evaluated. 3. Set M to result. B assert. Module is evaluated. C assert. Module is result. D perform. Call. Capability. Undefined. Result. 0. Else. A assert. Module is either evaluating async or evaluated. B assert. Module is empty. C if module is false, then I assert. Module is evaluated. 2. Perform. Call. Capability. Undefined. Undefined. D assert. Stack is empty. 1. Return capability. 6, 2, 1, 5, 3, 1. In a module evaluation. Module. Stack. Index. The abstract operation in a module evaluation takes arguments module, a module record, stack, a list of cyclic module records, and index, a non-negative integer, and returns either a normal completion containing a non-negative integer or a throw completion. It is used by evaluate to perform the actual evaluation process for module, as well as recursively on all other modules in the dependency graph. The stack and index parameters, as well as modules and fields, are used the same way as in inner module linking. It performs the following steps when called. If a module is not a cyclic module record, then a let promise be module evaluate. B assert. Promise state is not pending. C if promise is rejected, then I return throw completion. Promise D return index. 2. If module is either evaluating async or evaluated, then if module is empty, return index. B otherwise, return module. 3. If module is evaluating, return index. 4. Assert. Module is linked. 5. Set module to evaluating. 6. Set module to index. 7. Set module to index. 8. Set module to 0. 9. Set index to index plus 1. 10. Append module to stack. 11. For each string required of module, do a let required module be get imported module. Module required be set index 2. In a module evaluation, required module stack index. See if required module is a cyclic module record. Then I assert required module is one of evaluating async, or evaluated. 2. Assert. Required module is evaluating if and only if stack contains required module. 3. If required module is evaluating, then set module to min. Module required module if else. 1. Set required module to required module. 2. Assert. Required module is either evaluating async or evaluated. 3. If required module is not empty, return required module. V. If required module is true, then 1. Set module to module plus 1. 2. Append module to required module 2. If a module 0 or module is true, then 76. ECMA International 2024 AB. Assert. Module is false and was never previously set to true. Set module to true. See note. The order in which module records have their fields transition to true is significant. C1 6, 2, 1, 5, 3, 4. D if a module equals 0. Perform execute async module, module 13. Else, a perform module execute module 14. Assert. Module occurs exactly once in stack 15. Assert. Module 16. If a module equals module, then a let done be false. Be repeat. While done is false, I let required module be the last element of stack 2. Remove the last element of stack 3. Assert. Required module is a cyclic module record. If required module is false, set required module to evaluated. V otherwise, set required module to evaluating async. V. If required module and module are the same module record, set done to true. 7. Set rec ud module to module 17. Return index. Note 1a module is evaluating while it is being traversed by inner module evaluation. A module is evaluated on execution completion or evaluating async during execution if its field is true or if it has asynchronous dependencies. Note 2 any modules depending on a module of an asynchronous cycle when that cycle is not evaluating will instead depend on the execution of the root of the cycle via. This ensures that the cycle state can be treated as a single strongly connected component through its root module state. 6, 2, 1, 5, 3, to execute async module. The abstract operation execute async module takes argument module, a cyclic module record, and returns unused. It performs the following steps when called. 1. Assert. Module is either evaluating or evaluating async. 2. Assert. Module is true. 3. Let capability be. New promise capability. %promise %. 4. Let fulfilled closure be a new abstract closure with no parameters that captures module and performs the following steps when called. A performance and module execution fulfilled. Module be return undefined. 5. Let unfulfilled be create built-in function. Fulfilled closure 0, 6. Let rejected closure be a new abstract closure with parameters. Error. That captures module and performs the following steps when called. A performance and module execution rejected. Module. Error. Be return undefined. 7. Let onRejected be create built-in function. Rejected closure. 0, 8. Perform promise then. Capability. Unfulfilled. OnRejected. 9. Perform module execute module. Capability. 10. Return unused. 6, 2, 1. 5, 3, 3 gather available ancestors, module, exec list. The abstract operation gather available ancestors takes arguments module, a cyclic module record, and exec list, a list of cyclic module records, and returns unused. It performs the following steps when called. For each cyclic module record M of module, do. If exec list does not contain M and M is empty, then I assert M is evaluating async. ECMA International 2024 377. 2. Assert. M is empty. 3. Assert. M is true. 5. Assert. M, 0, V set M to M1V. If M equals 0, then 1. Append M to exec list. 2. If M is false, perform gather available ancestors. M, exec list. Return unused. 6, 2, 1, 5, 3, 4 async module execution fulfilled. Module. The abstract operation async module execution fulfilled takes argument module, a cyclic module record, and returns unused. It performs the following steps when called. 1. If module is evaluated, then A assert. Module is not empty. B return unused. 2. Assert. Module is evaluating async. 3. Assert. Module is true. 4. Assert. Module is empty. 5. Set module to false. 6. Set module to evaluated. 7. If a module is not empty, then A assert. Module is module. B perform. Call. Module. Undefined. Undefined. 8. Let exec list be a new empty list. 9. Perform gather available ancestors. Module. Exec list. 10. Let sorted exec list be a list whose elements are the elements of exec list, in the order in which they had their fields set to true and in a module evaluation. 11. Assert. All elements of sorted exec list have their fields set to true, field set to 0, and field set to empty. 12. For each cyclic module record M of sorted exec list, do if M is evaluated, then I assert M is not empty b else if M is true, then I perform execute a sync module MC else I let result be M execute module 2. If result is an abrupt completion, then perform a sync module execution rejected M result 3. Else 1. Set M to evaluated 2. If M is not empty, then I assert M is M. B perform. Call M undefined. Undefined. 3. Return unused. 6. 2. 1. 5. 3. 5 is sync module execution rejected. Module. Error. The abstract operation async module execution rejected takes arguments module, a cyclic module record, and error, an ECMA script language value, and returns unused. It performs the following steps when called. 1. If module is evaluated, then note when an asynchronous execution for a root module is fulfilled. This function determines the list of modules which are able to synchronously execute together on this completion, populating them in exec list. 78. ECMA International 2024. A assert. Module is not empty. B return unused. 2. Assert. Module is evaluating async. 3. Assert. Module is true. 4. Assert. Module is empty. 5. Set module to throw completion. Error. 6. Set module to evaluated. 7. For each cyclic module record M of module, do a performance and module execution rejected. M. Error. 8. If a module is not empty, then A assert. Module is module. B perform. Call. Module. Undefined. Error. 9. Return unused. 6. 2. 1. 5. For example cyclic module record graphs. This non-normative section gives a series of examples of the linking and evaluation of a few common module graphs, with a specific focus on how errors can occur. First, consider the following simple module graph. Figure 2. A simple module graph. Capital A, capital B, capital C. Let's first assume that there are no error conditions. When a host first calls a load requested modules, this will complete successfully by assumption, and recursively load the dependencies of B and C as well, respectively, C and none, and then set A equals B equals C equals unlinked. Then, when the host calls a link, it will complete successfully, again by assumption, such that A equals B equals C equals linked. These preparatory steps can be performed at any time. Later, when the host is ready to incur any possible side effects of the modules, it can call evaluate, which will complete successfully, returning a promise resolving to undefined, again by assumption. Recursively having evaluated first C and then B, each modules at this point will be evaluated. Consider then cases involving linking errors after a successful call to a load requested modules. If in a module linking of C succeeds but, thereafter, fails for B, for example because it imports something that C does not provide, then the original A link will fail, and both A and B's remain unlinked. C's has become linked, though. Finally, consider a case involving evaluation errors after a successful call to link. If in a module evaluation of C succeeds but, thereafter, fails for B, for example because B contains code that throws an exception, then the original A evaluate will fail, returning a rejected promise. The resulting exception will be recorded in both A and B's fields, and they will become evaluated. C will also become evaluated but, in contrast to A and B, will remain without an, as it successfully completed evaluation. Storing the exception ensures that any time a host tries to reuse A or B by calling their evaluate method, it will encounter the same exception. Hosts are not required to reuse cyclic module records. Similarly, hosts are not required to expose the exception objects thrown by these methods. However, the specification enables such uses. Now consider a different type of error condition. ECMA International 2024 379. Figure 3. A module graph with an unresolvable module capital A, question mark. In this scenario, module A declares a dependency on some other module, but no module record exists for that module. That is, host load imported module calls finished loading imported module with an exception when asked for it. This could occur for a variety of reasons, such as the corresponding resource not existing, or the resource existing but parse module returning some errors when trying to parse the resulting source text. Hosts can choose to expose the cause of failure via the completion they pass to finished loading imported module. In any case, this exception causes a loading failure, which results in A's remaining new. The difference here between loading, linking and evaluation errors is due to the following characteristic. Evaluation must be only performed once, as it can cause side effects. It is thus important to remember whether evaluation has already been performed, even if unsuccessfully, in the error case. It makes sense to also remember the exception because otherwise subsequent evaluate calls would have to synthesize a new one. Linking, on the other hand, is side effect free, and thus even if it fails, it can be retried at a later time with no issues. Loading closely interacts with the host, and it may be desirable for some of them to allow users to retry failed loads. For example, if the failure is caused by temporarily bad network conditions. Now, consider a module graph with a cycle. Figure 4. A cyclic module graph, BC. Here we assume that the entry point is module A, so that the host proceeds by calling a load requested modules, which performs in a module loading on A. This in turn calls in a module loading on B and C because of the cycle. This again triggers in a module loading on A, but at this point it is a no-op since A's dependencies loading has already been triggered during this load requested modules process. When all the modules in the graph have been successfully loaded, their transitions from new to unlinked at the same time, then the host proceeds by calling a link, which performs in a module linking on A. This in turn calls in a module linking on B because of the cycle. This again triggers in a module linking on A, but at this point it is a no-op since A is already linking. B itself remains linking when control gets back to A, and in a module linking is triggered on C. After this returns with C being linked. Both A and B transition from linking to linked together. This is by design. Since they form a strongly connected component, it's possible to transition the status of modules in the same SCC at the same time because during this phase the module graph is traversed with a depth-first search. An analogous story occurs for the evaluation phase of a cyclic module graph. In the success case, now consider a case where A has a linking error. For example, it tries to import a binding from C that does not exist. In that case, the above steps still occur, including the early return from the second call to inner module linking on A. However, once we unwind back to the original inner module linking on A, it fails during initialize environment, namely right after C resolve export. The thrown syntax error exception propagates up to a link, which resets all modules that are currently on its stack. These are always exactly the modules that are still linking. Hence both A and B become unlinked. Note that C is left as linked. 80. Copyright sign, ECMA International 2024. Alternatively, consider a case where A has an evaluation error. For example, its source code throws an exception, capital I. In that case, the evaluation time analog of the above steps still occurs, including the early return from the second call to inner module evaluation on A. However, once we unwind back to the original inner module evaluation on A, it fails by assumption. The exception thrown propagates up to A evaluate, which records the error in all modules that are currently on its stack. That is, the modules that are still evaluating, as well as via, which form a chain for modules which contain or depend on top. Level await through the whole dependency graph through the async module execution rejected algorithm. Hence both A and B become evaluated and the exception is recorded in both A and B's fields, while C is left as evaluated with no. Lastly, consider a module graph with a cycle, where all modules complete asynchronously. Figure 5. An asynchronous cyclic module graph, capital A, B, C, D, loading and linking happen as before, and all modules end up with set to linked. Calling evaluate calls in a module evaluation on A, B, and E, which all transition to evaluating. Then in a module evaluation is called on A again, which is a no-op because it is already evaluating. At this point, D is 0, so execute a sync module, D, is called and we call the execute module with a new promise capability tracking the asynchronous execution of D. We unwind back to the inner module evaluation on B, setting B to 1 and B to true. We unwind back to the original inner module evaluation on A, setting it to 1. In the next iteration of the loop over A's dependencies, we call in a module evaluation on C and thus on D, again in no-op, and E as E has no dependencies and is not part of a cycle. We call execute a sync module, E. In the same manner as D and E is immediately removed from the stack. We unwind once more to the original inner module evaluation on A, setting C to true. Now we finish the loop over A's dependencies, set A to true, and remove the entire strongly connected component from the stack, transitioning all of the modules to evaluating a sync at once. At this point, the fields of the modules are as given in Table 46. Table 46. Module fields after the initial evaluate. Call. Fields. Modules. Capital A. Capital B. Capital C. Capital D. Capital E. DFS index. DFS ancestor index. Status. Evaluating async. Async evaluation. True. 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 Async parent modules. Double angle quotation mark. A. B. C, pending async dependencies, B and C, D and D, ECMA International 2024, 81. Let us assume that D finishes executing first. When that happens, async module execution fulfilled is called, E is set to evaluated and C is decremented to become 1. The fields of the ed modules are as given in Table 47. Table 47. Module fields after module finishes executing. Fields. Modules. Capital C. Capital E. DFS index. DFS ancestor index. Status. Evaluating async. Evaluated. Async evaluation. True. True. Async parent modules. A. C. Pending async dependencies. D. D is next to finish, as it was the only module that was still executing. When that happens, async module execution fulfilled is called again and D is set to evaluated. Then B is decremented to become 0. Execute async module is called on B, and it starts executing. C is also decremented to become 0, and C starts executing, potentially in parallel to B if B contains an await. The fields of the updated modules are as given in Table 48. Table 48. Module fields after module D finishes executing. Fields. Modules. Capital B. Capital C. Capital D. DFS index. DFS ancestor index. Status. Evaluating async. Evaluating async. Evaluated. Async evaluation. True. 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 Async parent modules. A. B. C. Pending async dependencies. Let us assume that C finishes executing next. When that happens, async module execution fulfilled is called again. C is set to evaluated and A is decremented to become 1. The fields of the updated modules are as given in Table 49. Table 49. Module fields after module C finishes executing. Fields. Modules. Capital A. Capital C. DFS index. DFS ancestor index. Status. Evaluating async. Evaluated. 82. ECMA International 2024. Table 49. Module fields after module C finishes executing. Continued. Fields. Modules. Capital A. Capital C. Async evaluation. True. True. Async parent modules. Double angle quotation mark. A. Pending async dependencies. B. Then.
Finally, done finding and replacing.
Module execution.
Now every single operation that needs to be evaluated is tagged with QQ.
Is called and it starts executing.
So the whole fucking program, 32-bit engine.
Table 50. Module fields after module B finishes executing. Fields, modules, capital A, capital B, DFS index, DFS ancestor index, status, evaluating async, evaluated, async evaluation, true, true, async parent modules, double.
I can do Control F for QQ,
Finally, a finishes executing.
and it will find every operation that needs to be evaluated.
Evaluated. At this point, the promise in A, which was returned from A evaluate, is resolved, and this concludes the handling of this module graph. The fields of the updated
That's finally done and over with.
module fields are
That took way too long.
fields, modules, capital A, DFS index, DFS ancestor index, S, status, evaluated, async evaluation,
So it's done.
modules, double angle quotation.
Fucking done. All 15,000 done.
Consider a failure case where C fails execute.
So now all the operations, every single operation that needs to be evaluated to figure out if it works with 64-bit is tagged with QQ.
National 2020.
Every single increment, decrement, positive, negative, add, subtract, plus equal, minus equal, tilde not, logical not, multiply, multiply equal, divide, divide assign, module, module assign, and assign, and, the logical and, XOR, assign, or assign, or logical or, shift left assign, shift right assign. Every single operation.
Modules, double angle quotation mark, A.
All I have to do is Control F on QQ.
Error, or will be rejected with the same error as C since C will call us an modular execution.
In the entire program, the 32-bit engine I have that I wrote 78 years ago,
As an A, which was returned.
all I have to do is Control F on QQ,
Fields of the updated modular as
and there are
Table 53. Module fields after module A is rejected. Fields, modules, capital A, DFS index, DFS.
exactly only
Evaluated, async evaluation, true, async parent modules, double angle quotation mark, pending async dependencies, evaluation,
15,000 matches across 114 files.
an error. When that happens, async modular
So those other files out of the 158
evaluated,
are like includer files that don't have operations, or prototype files that have the function prototypes,
not be added.
but there's no operation to like check or whatever.
Field will return without further processing. Any future importer of rejection of B from the evaluation error from C that was set
So all I have to do is go through these 15,000 matches,
484. Copyright sub
look at every single operation from left to right,
4. Module fields after module B finishes executing in an erroring graph. Fields, modules, capital A, capital B, DFS index, DFS ancestor index, status, evaluated, evaluated, async evaluation, true, true, async parent modules, double angle quotation mark, A, pending async dependencies, evaluation error, C's evaluation error, empty, 6, 2, 1. 6 source text module records. A source text module record is used to represent information about a module.
trying to find something that's more complicated.
11. That was parsed using the goal symbol module. Its fields contain digested information about the names that are imported and exported by the module, and its concrete methods use these digests to link and evaluate the module. A source text module record can exist in a module graph with all subclasses of the abstract module record type, and can participate in cycles with other subclasses of the cyclic module record type, in addition to the fields defined in Table 43. Source text module records have the additional fields listed in Table 55. Each of these fields is initially set in parse module, Table 55. Additional fields of source text module records, field name, value type, meaning, ECMA script code, a parse node.
It's mostly just boring control flow,
Goal symbol.
like loops
Context.
or code blocks, not even like, where's the code? It has to be somewhere in the middle.
Environment has been initialized. Import import meter, an object, or empty, an object exposed through the import meter meta property. It is empty until it is accessed by ECMA script code. Import entries, a list of import entry records, a list of import entry records derived from the code of this module. Local export entries, a list of export entry records, a list of export entry records derived from the code of this module that correspond to declarations that occur within the module. Indirect export entries, a list of export entry records, a list of export entry records derived from the code of this module that correspond to re-exported imports that occur within.
Oh, like here, I guess.
Declarations, ECMA International 2024, 85, Table 55. Additional fields of source text module records. Continued. And
I can go each file, whatever. Look for QQ. And if it looks like it's okay, so like this looks fine, this will convert to 64-bit. I just get rid of a Q.
import entry record fields. Field name.
And I check the next one. This one, that's fine. That's fine, that's fine, that's fine.
Of export.
So I get rid of the Q.
The code of this module that corresponds to export declarations that occur within the module, not including
Check the next one. So like this one is probably fine.
a string value,
But if I had to worry about overflow,
string or name
or there's some reason that I don't want to check it right now, I want to come back to it later,
by
I can skip it
object indicate
and oh, this one looks okay or something. So I can go through the whole thing one by one.
string the name
When I'm all done, I can do Control F again.
value from within the importing module.
And anything that is skipped will still be tagged with QQ. So anything I skip, I can come back later, I can find it, because it's still tagged.
Mappings to import entry.
And I come back to it, I can check, oh, this looks fine, it's size T, so this looks okay.
Import
And I get rid of the Q.
mod namespace object ns import x
At some point, when I do Control F, if there's no more matches
mod
for QQ,
import mod an import entry record is not created.
then it means I'm done, that this entire thing is 64-bit.
Single declarative
That took 2 fucking weeks to tag everything. But now, I can go through the entire program, freaking,
54 table 58 export
not mechanically, what's the word?
view type meaning export name to export this binding by the
It's not meticulously,
test a string
systematically, and I can go through the whole file, all the files, systematically, find a QQ, replace with Q, when it's been checked and looks okay for 64-bit, and when I'm done, the entire thing will run as 64-bit.
by nullify
Hypothetically, theoretically, physically, it should just work. And it's done, or whatever. So I don't have to go back through, check files, check this, check that. It literally will just work.
the name that is
Because I tagged every single place, so now I don't have to sort the files, go through one by one. I've done all that. I've done all that by tagging it, by replacing the operand. So I don't know. This was totally worth it.
what forms table 59
This saves so much time.
forms mappings to export entry records export statement form export name module
So I'm almost ready to get started.
rv v
And start putting the engine together.
default function f default null f
Oh my god, that takes so long to do.
default null
I never want to do that again.
default null
It's fucking hell.
export x null x export v as x null v export x
So I have to run it, make sure it builds, save back up.
export v as
I'm gonna save it back up to another drive, whatever.
from mod null mod
It's like a checkpoint, because if I screw it up, I'm screwed, so I need a really good, solid backup.
specify the required concrete methods and other abstract operations
So I'm gonna run it, save it back up, and I'll get back to this, and then I have to
or 387 6
start on the parser.
6 1 parse
I could increase the font size instead.
helm host defined. The abstract operation parse module takes argument source text ECMA script source text realm a realm record
I'll just call it a lexicon. I don't care, it doesn't matter.
Or a non-empty list of syntax error objects. It creates a source
So I think I'll just call it a lexicon, the file, whatever it is.
text as a module.
So I need to make the lexicon parser first.
1. Let body be parse text.
I need to account for UFT8 encoding, UFT16 encoding, whatever encoding they need to support. I gotta account for that.
Body.
So the web browser,
Entries be import entries of body. 5. Let imported bound names be imported local names. Import entries.
when they do the parsing, whatever,
Let local export
they can handle all this on their own. If I sell it to the browser, if I decide to, I might not decide to. I just might make my own standalone game engine, or sell it to Unity, or not. I don't know, it depends.
record EE of export entries. Do if EE is null.
If YouTube's not gonna treat me fairly with promoting my videos and streams, and if they're gonna play games with the analytics, I see no reason to sell it to YouTube, or Google, or Alphabet. They're all the same company.
Is namespace object.
So I can I don't know, whatever. I can do whatever I want. I have tons of options.
D to local export entries. Else a note.
I can go down any of those options, any of those avenues, any of those routes, whatever I pick. All of it's available. I'm not pigeonholed.
Indirect export entries. BL.
I'm the pigeon making fucking holes.
EE is null. 2.
So the web browser does parsing, however it does it.
11.
If I decide to release it to them, if they want it, whatever, I already talked about that.
Empty. Empty.
I don't have to, I can do whatever I want. I can make an image and stuff if I wanted.
Empty.
If so though, they would handle the file encoding and stuff, and they would just put stuff to
Rules. Import entries. Local export entries. Indirect.
the lexicon file that get passed in.
Empty. Empty. 6.
So they would just need to generate the lexicon file, and that would get passed to my engine, and my engine would handle it. My engine would handle it from there. Except I need to make a parser to make the file and add stuff to the file, get stuff set up.
It performs the following steps.
So this parser is for me, and I guess I'd sell it with the engine, but they'd keep their parser that they have. They just add to it.
Set export star set to a new empty list.
Because they spent a lot of time and money to develop the parser that they have, so they're not going to change it. I wouldn't expect them to. All they'd have to do is convert it, the data, to the table, and then it would run. So they can use what they have and just plug in my engine. If I release it to them, if they decide to buy it, all circumstantial.
8.
I'm speaking hypothetically.
ECMA International 2024.
So,
Export circularity. B return a new empty list.
I'm gonna have to count for at least UFT16 just for my parser, and then the more obscure types or parsers, not parsers, file types, I could deal with those later. I just need to get the basic.
Cert. Module.
So we'll decode the file correctly, and then build the lexicon file.
7. For each export entry record D of module. Do AS RT module imports.
I'm gonna have to optimize things for xe6 and ARM64
Null. See append.
at the same time, not just do one and then do the other, because I'll forget to do one or the other.
Insert.
Except I'm also going to account for async and threading,
See let star names be requested module get
because we'll need to take breaks while it's parsing to do other things.
do I
And then threading can relate to the whole file, so I could set a thread for each file if there's more than one file in the file, in the JavaScript file that makes up the web page, whatever.
2.
Or I could set up threads to work on parts of the file at a time. So if it's a 5 kilobyte file, one thread could work on
A string and optional argument results
the upper
with fields, a module record, and a string and returns a resolved binding record. Null or ambiguous.
So if it's like a 5 kilobyte file, I could have one thread work on the upper 2.5 kilobytes, and the other thread work on the lower 2.5 kilobytes, or megabytes, I mean.
Presented by the module record, this method was invoked on or some other module that is imported by that module. The parameter resolve set is used to detect unresolved circular import-export paths. If a pair consisting of specific module record and export name is reached that is already in resolve set, an import circularity has been encountered. Before recursively calling resolve export, a pair consisting of module and export name.
So you could like set up threads to like work on different parts of the file. And then there'd have to be like another thread to handle the overlap in between.
If a defining module is found, a resolve
Which is what the main thread could do.
record
So maybe I'll set up the threads to work on different chunks, and then the main thread could run
base with no local binding. In this case,
and handle the async, but in a way that like
null is
the main thread would like do 10, 20, however many of like these merger between the files it has to do,
pulled.
and then take a break, and then do another chunk, and then do another chunk, so that way the main thread would only have to like tie the chunks together between where the threads meet, or they split the file.
3. For each record, R of resolve
Or I could have the threads work on separate files individually.
module record in same value. Export name, R, is true. Then, I assert, this is a circular import request. 2. Return null. 4. Append the record, module, export name, to resolve set. 5. For each export entry record E of module, do if same value, export name, E, is true. Then, I assert, module provides the direct binding for this export. 2. Return resolved binding record, module, E. For each export entry record E of module, do if same value, export name.
Of course it's not working, whatever.
International 2024, 300 and...
So, I don't know. Async, threading. I have to deal with the buffer size. Some computers won't be able to handle big buffers.
I assert,
In the malloc, I have a slab allocator. I have it set up for 4 kilobyte chunks.
is all, then.
I might need to just use it, have how I have it set up, and then not modify it till later.
2.
Because I just got it running.
Namespace,
I still need to add like leafy data structures for hash tables and stuff.
for this export. 2.
But I'm gonna have to make allocation calls, and I want to try to use that API from the start. This will be easier to work with later, and I don't have to call malloc.
Export was not explicitly defined by this module. B return null. 8C note. A default
So lexicon parser is different than the lexicon compiler.
expression be null. 10.
This is parser, this is compiler.
You'll do. Assert.
They're like two separate steps.
Module B get imported module. Module E. C let resolution be imported module resolve export.
And then the lexicon compiler
If resolution is ambiguous, return ambiguous. E if resolution null, then I assert resolution is a resolved binding record. 2. If star resolution is null, then set star resolution to resolution.
which will compile the output from the lexicon parser.
Import that includes
So I guess it'd be called the file.
if resolution and star resolution are not the same module record, return ambiguous. 3. If resolution is not star resolution and either resolution or star resolution is namespace, return ambiguous. 4. If resolution is a string, star resolution is a string, and same value, resolution, star resolution, is false, return ambiguous. 0. Return star resolution. 6, 2, 1, 6. For initialize environment, The initialize environment concrete method of a source text module record module takes no arguments and
So the parser would make the file.
throw completion. It performs the following steps when called. 1. For each export,
And the file will be passed into the compiler.
assert. It is not null. B let resolution B module resolve export.
So lexicon compiler, it doesn't have to deal with
A syntax
the encoding and stuff because it's going to work with the formatted dictionary, whatever, of everything.
solvable. 3.
So this is easier.
Module 4.
It would have to loop through, pull out the keywords, do some static analysis on the data, control flow, structure, tokens, whatever.
To env.
It'd have to like validate the syntax to make sure it doesn't break rules.
Do a let imported module be get imported module.
It would also have to be async,
Then I let
account for threading, buffer size, and malloc.
perform env created.
At least doesn't have to deal with the file encoding. That's why I want to break it up in a way that the file encoding part gets separated from the parser. So this way this file,
2024. I2. Let resolution
it's the middleman. It encompasses all the logic and stuff without having to deal with different file formats because there's tons of different, you can make HTML file, a CSS file, I don't know, different encodings too.
module namespace.
So that way that's all handled up here, and then this is like a plain data blob that's formatted to be parsed and then generated to C code.
Namespace. I've
So from this would make the actual JavaScript into C to run C, or run JavaScript at C language speed.
execution context. 9. Set the function of module context to null. 10. Assert. Module is not undefined. 11. Set the realm of module context to module. 12. Set the script or module of module
Is that useful compiler? I don't know, it doesn't matter.
set the variable and
I need some water.
context to module. 14. Set the lex module context to module. 15. Set the private environment.
So that gets passed in, it makes a C file, makes a C program, it compiles it,
17.
and that C compiled program, whatever,
X stack. Module context is now the running execution context.
it'll get assigned
Let code be
to the resizable lookup tables, whereas code.
declarations be the var scope dec
So that's like the next step. So first I need to get
var names be a new empty list.
the lexicon parser, like I just described, whatever.
Var declarations. Do a free
That needs to be done first,
D. Do I have declared
before I can even bother to deal with the rest of it. Below, whatever.
v create mutable binding. dn
So all this stuff doesn't matter right now.
binding. dn undefined.
All I need to do is focus on this part.
Declared var names. 22. Let lex declarations be the lex
And then I'll be good. So I have to focus on that, making the parser part.
for each element d of lex
I already kind of know how it's going to be set up after that.
bound names of d. Do I have this constant declaration of
And I have to go through, finish up converting everything to 64-bit.
dn true to else before me n
I have everything tagged so I can find all the operations.
if d is either a function
I have to go through one by one, convert them. At that point,
function declaration or an async generator declaration
I will merge everything that's converted
function object
with the lexicon compiler
before me env
and actually generate the C program, the JavaScript to C.
text from the execution context stack 20
So I need this first.
boost
I need to finish converting it, and then I can at this point, I need everything ready, and then it's ready. And then from this point on,
module record module takes optional argument
I can go through the standard,
ability record and returns either an
the ECMA 262,
or a throw completion. It performs the
and then I'm cooking with fire. And anyone wants to play, if they want to play fire, they can get burned, or whatever the fuck they want. The audio's stuck, that's cool. So, I don't know. You know what? Nothing's fucking working. LBRB.
Two, set the function of module context to null. 3. Set the realm of module context to module. 4. Set the script or module of module context to module. 5. Assert. Module has been linked and declarations in its module environment have been instantiated. 6. Set the variable environment of module context to module. 7. Set the lexical environment of module context to module. 8. Suspend the running execution context. 9. If a module is false, then A assert capability is not present. B push module context onto the execution context stack. Module context is now the running execution context. C let result be completion. Evaluation of module ECMA International 2024 391. D suspend module context and remove it from the execution context stack. E resume the context that is now on the top of the execution context stack as the running execution context. F if result is an abrupt completion, then I return result 10. Else A assert capability is a promise capability record. B perform a sync block start capability module context 1. Return unused 6 2 1 7 get imported module referrer specifier. The abstract operation get imported module takes arguments referrer, a cyclic module record, and specifier, a string, and returns a module record. It performs the following steps when called. 1. Assert. Exactly one element of referrer is a record whose is specifier, since load requested modules has completed successfully on referrer prior to invoking this abstract operation. 2. Let record be the record in referrer whose is specifier. 3. Return record. 6 2 1 8 host load imported module referrer specifier host defined payload. The host defined abstract operation host load imported module takes arguments referrer, a script record, a cyclic module record, or a realm record, specifier, a string, host defined anything, and payload. A graph loading state record or a promise capability record, and returns unused. Note an example of when referrer can be a realm record is in a web browser host. There, if a user clicks on a control given by button type equals button on click equals import foo mjs click me button, there will be no active script or module at the time the import expression runs. More generally, this can happen in any situation where the host pushes execution contexts with null script or module components onto the execution context stack. An implementation of host load imported module must conform to the following requirements. The host environment must perform finish loading imported module, referrer, specifier, payload, result, where result is either a normal completion containing the loaded module record or a throw completion, either synchro now. Sly or asynchronously. If this operation is called multiple times with the same referrer, specifier, pair and it performs finish loading imported module, referrer, specifier, payload, result, where result is a normal completion. Then it must perform finish loading imported module, referrer, specifier, payload, result, with the same result each time. The operation must treat payload as an opaque value to be passed through to finish loading imported module. The actual process performed is host-defined, but typically consists of performing whatever I/O operations are necessary to load the appropriate module record. Multiple different referrer, specifier, pairs may map to the same module record instance. The actual mapping semantics is host-defined, but typically a normalization process is applied to specifier as part of the mapping process. A typical normalization process would include actions such as expansion of relative and abbreviated path specifiers. '92, copyright sign, ECMA International 2024, 6, 2, 1, 9 finish loading imported module, referrer, specifier, payload, result. The abstract operation finish loading imported module takes arguments referrer, a script record, a cyclic module record, or a realm record, specifier, a string, payload, a graph loading state record or a promise capability record, and result. Either a normal completion containing a module record or a throw completion, and returns unused. It performs the following steps when called. If result is a normal completion, then if referrer contains a record whose is specifier, then I assert that records is result be else. I append the record, specifier, result, to referrer. If payload is a graph loading state record, then I perform continue module loading, payload, result. Else I perform continue dynamic import, payload, result, return unused. 6, 2, 1, 1, 0 get module namespace, module. The abstract operation get module namespace takes argument module, an instance of a concrete subclass of module record, and returns a module namespace object or empty. It retrieves the module namespace object representing modules exports, lazily creating it the first time it was requested, and storing that in module for future retrieval. It performs the following steps when called. 1. Assert. If module is a cyclic module record, then module is not new or unlinked. 2. Let namespace be module. 3. If namespace is empty, then a let exported names be module get exported names. B let unambiguous names be a new empty list. C for each element name of exported names, do. I let resolution be module resolve export, name 2. If resolution is a resolved binding record, append name to unambiguous names. D set namespace to module namespace create, module, unambiguous names 4. Return namespace 6, 2, 1, 1, 1 runtime semantics, evaluation module, empty, return undefined. Module body, module item list 1. Let result be completion, evaluation of module item list 2. If result is a normal completion and result is empty, then a return undefined 3. Return result. Module item list. Module item list. Module item 1. Let SL be evaluation of module item list. 2. Let S be completion, evaluation of module item. 3. Return. Update empty, S, SL. Note get module namespace never throws. Instead, unresolvable names are simply excluded from the namespace at this point. They will lead to a real linking error later unless they are all ambiguous star exports that are not explicitly requested anywhere. ECMA International 2024 393. Note the value of a module item list is the value of the last value producing item in the module item list. Module item, import declaration. Return empty 16. 2 import syntax. Import declaration. Import clause from clause. Import module specifier. Import clause. Imported default binding. Namespace import. Named imports. Imported default binding. Namespace import. Imported default binding. Named imports. Imported default binding. Imported binding. Namespace import as imported binding. Named imports. Imports list. Imports list. From clause. From module specifier. Imports list. Import specifier. Imports list. Import specifier. Import specifier. Imported binding. Module export name as imported binding module specifier. String literal imported binding. Binding identifier. Yield. Plus await. 16. 2. 1 static semantics. Early errors. Module item. Import declaration. It is a syntax error if the bound names of import declaration contains any duplicate entries. 94. Copyright sign. ECMA International 2024. 6. 2 static semantics. Import entries. The syntax-directed operation import entries takes no arguments and returns a list of import entry records. It is defined piecewise over the following productions. Module. Empty. Return a new empty list. Module item list. Module item list. Module item 1. Let entries 1 be import entries of module item list. 2. Let entries 2 be import entries of module item. 3. Return the list concatenation of entries 1 and entries 2. Module item. Export declaration. Statement list item. Return a new empty list. Import declaration. Import clause from clause. 1. Let module be the sole element of module requests of from clause. 2. Return import entries for module of import clause with argument module. Import declaration. Import module specifier. 1. Return a new empty list. 6. 2. 3 static semantics. Import entries for module. The syntax-directed operation import entries for module takes argument module, a string, and returns a list of import entry records. It is defined piecewise over the following productions. Import clause. Imported default binding. Namespace import. 1. Let entries 1 be import entries for module of imported default binding with argument module. 2. Let entries 2 be import entries for module of namespace import with argument module. 3. Return the list concatenation of entries 1 and entries 2. Import clause. Imported default binding. Named imports. 1. Let entries 1 be import entries for module of imported default binding with argument module. 2. Let entries 2 be import entries for module of named imports with argument module. 3. Return the list concatenation of entries 1 and entries 2. Imported default binding. Imported binding. 1. Let local name be the sole element of bound names of imported binding. 2. Let default entry be the import entry record. Module. default. Local name, local name. 3. Return default entry. Namespace import, as imported binding. 1. Let local name be the string value of imported binding. 2. Let entry be the import entry record, module, namespace object. Local name, local name. 3. Return entry, ECMA International 2024 395. Named imports, return a new empty list. Imports list, import specifier. 1. Let specs1 be the import entries for module of imports list with argument module. 2. Let specs2 be the import entries for module of import specifier with argument module. 3. Return the list concatenation of specs1 and specs2. Import specifier, imported binding. 1. Let local name be the sole element of bound names of imported binding. 2. Let entry be the import entry record, module, local name. Local name, local name. 3. Return entry. Import specifier, module export name as imported binding. 1. Let import name be the string value of module export name. 2. Let local name be the string value of imported binding. 3. Let entry be the import entry record, module, import name, local name, local name. 4. Return entry. 6. 2. 3. Export syntax. Export declaration. Export from clause. Export named exports. Export variable statement, yield, plus await. Export declaration, yield, plus await. Export default hoistable declaration, yield, plus await, plus default. Export default class declaration, yield, plus await, plus default. Export default, look ahead. Function, async. No line terminator here. Function. Class, assignment expression, plus in, yield, plus await. Export from clause. As module export name named exports. Named exports. Exports list. Exports list. Exports list. Export specifier. Exports list. Export specifier. Export specifier. Module export name. 96. ECMA International 2024. Module export name as module export name. 6. 2. 3. 1. Static semantics. Early errors. Export declaration. Export named exports. Comma, it is a syntax error if reference bindings of named exports contains any string literals. Comma, for each identifier name n in referenced bindings of named exports, it is a syntax error if string value of n is a reserved word or the string value of n is 10. F implements interface, let, package, private, protected, public, or static. 6. 2. 3. 2. Static semantics, exported bindings. The syntax-directed operation exported bindings takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module item list, module item list, module item 1. Let names 1 be exported bindings of module item list. 2. Let names 2 be exported bindings of module item 3. Return the list concatenation of names 1 and names 2. Module item, import declaration, statement list item, return a new empty list. Export declaration. Export from clause. 1. Return a new empty list. Export declaration, export named exports. Return the exported bindings of named exports. Export declaration, export variable statement 1. Return the bound names of variable statement. Export declaration, export declaration 1. Return the bound names of declaration. Export declaration, export default hoistable declaration, export default class declaration, export default assignment expression. Return the bound names of this export declaration. Note the above rule means that each reference bindings of named exports is treated as an identifier reference. Note exported bindings are the locally bound names that are explicitly associated with the module's exported names. ECMA International 2024 397. Named exports, return a new empty list. Exports list, exports list, export specifier. 1. Let names 1 be the exported bindings of exports list. 2. Let names 2 be the exported bindings of export specifier. 3. Return the list concatenation of names 1 and names 2. Export specifier, module export name. Return a list whose sole element is the string value of module export name. Export specifier, module export name as module export name. Return a list whose sole element is the string value of the first module export name. 6, 2, 3. 3 static semantics. Exported names. The syntax-directed operation exported names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Module item list, module item list, module item. 1. Let names 1 be exported names of module item list. 2. Let names 2 be exported names of module item. 3. Return the list concatenation of names 1 and names 2. Module item. Export declaration. Return the exported names of export declaration. Module item. Import declaration. Statement list item. Return a new empty list. Export declaration. Export from clause. Return the exported names of export from clause. Export from clause. Return a new empty list. Export from clause. As module export name. Return a list whose sole element is the string value of module export name. Export from clause. Named exports. Return the exported names of named exports. 98. ECMA International 2024. Note exported names are the externally visible names that a module explicitly maps to one of its local name. Bindings. Export declaration. Export variable statement 1. Return the bound names of variable statement. Export declaration. Export declaration 1. Return the bound names of declaration. Export declaration. Export default hoistable declaration. Export default class declaration. Export default assignment expression. Return default. Named exports. Return a new empty list. Exports list. Exports list. Export specifier. 1. Let names 1 be the exported names of exports list. 2. Let names 2 be the exported names of export specifier. 3. Return the list concatenation of names 1 and names 2. Export specifier. Module export name. Return a list whose sole element is the string value of module export name. Export specifier. Module export name as module export name. Return a list whose sole element is the string value of the second module export name. 6, 2, 3, 4 static semantics. Export entries. The syntax-directed operation export entries takes no arguments and returns a list of export entry records. It is defined piecewise over the following productions. Module. Empty. Return a new empty list. Module item list. Module item list. Module item 1. Let entries 1 be export entries of module item list. 2. Let entries 2 be export entries of module item 3. Return the list concatenation of entries 1 and entries 2. Module item. Import declaration. Statement list item. Return a new empty list. Export declaration. Export from clause 1. Let module be the sole element of module requests of from clause. 2. Return export entries for module of export from clause with argument module. ECMA International 2024 399. Export declaration. Export named exports. Return export entries for module of named exports with argument null. Export declaration. Export variable statement. 1. Let entries be a new empty list. 2. Let names be the bound names of variable statement. 3. For each element name of names, do A. Append the export entry record, null, name, to entries. Return entries. Export declaration. 1. Let entries be a new empty list. 2. Let names be the bound names of declaration. 3. For each element name of names, do A. Append the export entry record, null, name, to entries. Return entries. Export declaration. Export default hoistable declaration. 1. Let names be bound names of hoistable declaration. 2. Let local name be the sole element of names. 3. Return a list whose sole element is a new export entry record, null. Local name, default. Export declaration. Export default class declaration. 1. Let names be bound names of class declaration. 2. Let local name be the sole element of names. 3. Return a list whose sole element is a new export entry record, null. Local name, default. Export declaration. Export default assignment expression. 1. Let entry be the export entry record, null, default. 2. Return entry. 6, 2, 3, 5 static semantics. Export entries for module. The syntax-directed operation export entries for module takes argument module, a string or null, and returns a list of export entry records. It is defined piecewise over the following productions. Export from clause. Two. Let entry be the export entry record, module, all but default, null. Return entry. (0, 0). ECMA International 2024. Note default is used within this specification as a synthetic name for anonymous default export values. See this note for more details. Export from clause as module export name. 1. Let export name be the string value of module export name. 2. Let entry be the export entry record. Module, all, null. Export name, export name. 3. Return entry. Named exports. Return a new empty list. Exports list, exports list, exports specifier. 1. Let specs1 be the export entries for module of exports list with argument module. 2. Let specs2 be the export entries for module of exports specifier with argument module. 3. Return the list concatenation of specs1 and specs2, export specifier, module export name. 1. Let source name be the string value of module export name. 2. If a module is null, then a let local name be source name. B let import name be null. 3. Else a let local name be null. B let import name be source name. 4. Return a list whose sole element is a new export entry record. Module, import name, local name, source name. Export specifier, module export name as module export name. 1. Let source name be the string value of the first module export name. 2. Let export name be the string value of the second module export name. 3. If a module is null, then a let local name be source name. B let import name be null. 4. Else a let local name be null. B let import name be source name. 5. Return a list whose sole element is a new.
There's like several big tech companies that are like dying.
6.
They're barely like hanging on.
Semantics, referenced bindings.
And the last thing
Reference.
that's gonna happen to me is not me getting screwed. I'm not gonna get screwed.
Find piecewise over the following.
So I don't know. They're so shady in the first place. Anyways. There's like a whole bunch of stuff I gotta do.
Exports list, exports list, exports
I have a network drive. I have to pull out the Wi-Fi from it, the Wi-Fi chip, make sure it still works. It has offline over the Ethernet. I have to connect a couple computers to that drive so it's all offline.
module export name
I need to like install Linux.
of the first module export name. ECMA in
I need to clone Linux.
401.
So if I need to like install software later,
Module export name.
I can install software to the clone on a different computer that doesn't even touch the computer I'm working on.
Module.
So it'll be completely isolated. And then I can like access the network drive from that install.
7 run.
So everything will be compartmentalized and stuff or whatever.
Export from clause.
And like easy to manage.
Return empty.
I gotta find the drive. And I gotta open it. Gotta find a screwdriver kit.
Statement.
I gotta pull out the chip. Gotta make sure it still works. There's a possibility that it could stop working when the chip's removed.
Export default.
So that would really suck. I'd have to buy something online then.
Of hoistable declaration. Export declaration. Export default. Declaration. Let capital B I.
I have to get off Windows. Which this computer is right now, it's Windows. I need to get off Windows onto Linux.
S.
I'm not going to deal with the Windows 64-bit API and stuff because it sucks.
A. T. I.
Nothing runs Windows other than desktop.
V A L.
Every other like device runs some form of Linux or whatever.
Let class name be the sole element of bound names of class. Default value env. 4. Return empty. Export declaration. Export default assignment expression. If is anonymous function definition, assignment expression is true.
And I have the file structure that I planned out months ago,
With argument default.
all set up or whatever.
2. Else let RHSB. Evaluation.
Maybe 2 months. Unfortunately, 2 months. Took way too long to get to this point.
3. Let env be the running execution context's lexical environment. 4. Perform. Initialize bound name. Default.
So I have to move everything to this folder.
Handling and language extensions.
I need to organize the projects,
Report most
make sure they all run separately in this new folder structure.
evaluated
And this folder needs to be moved to
and reported prior to the evaluation of any
the
containing the error. The presence of an early error prevents the evaluation of the construct. An implementation
hard drive, whatever. That's, I think it's called a NAT.
script. Early errors in a module are reported at the point when the module would be evaluated and the module is never initialized. Early errors in
Having YouTube open is probably locking down the browser. I mean bogging down, not locking down. I just drank pop way too fast. My stomach's gonna explode. It's called a NAS, not a NAT. So it has like an Ethernet plug.
0.
You plug in the Ethernet and you can plug in a switch box. You can have like 70 computers connected to a single drive, whatever. So you don't need to have a whole server set up. I have enough computers turned on right now. I don't need a server too. And servers are extremely loud. Freaking, they're so loud. I can't handle the fans from server. I would have to like put the server in the garage or something. So fucking loud.
Eval code are reported at the time eval is called and prevent evaluation of the eval code. All time errors.
So I can end the stream. Why is the sound not working? So I don't know. I gotta like figure out stuff. I think that this diagram sucked. And this diagram possibly makes more sense than this one did. Because this diagram has sucked. I don't know. I think having the paint program, whatever you call it, open is like messing with the sound software and making it crash more. So I don't know what to do. There's so much to do. I can't possibly do everything at the same time. I'm kind of at a wall. I gotta pick something. I also have to make documentation. Maybe I'll start on that. I think I'm gonna go like walk around in a circle and figure out what to do. And then go on from there, whatever. I just gotta pick something. But now there's like so many things to pick from. So, I don't know. I'll BRB. Maybe not like right back. Maybe a bit. I need to find that drive. I need to find screwdriver kit. I gotta set up to install Linux. I have to find the backup project. I gotta move things to the backup drive. Then I'm gonna connect to the computers too. I gotta get started on something. So, ow, BRB. First, I gotta restart the Mac, because it's shit. The sound stops working every 2-3 minutes. I guess I'll run the program, make sure so it works. What's with everything updating? It's so annoying. I forgot to save chatbot. Its history. Dang it. So like, I don't know. I finished finding replacing. I'm gonna like check if it builds still. It should still build. It takes a freaking minute every time. What's 1010 mean? If I was gonna be like, what's the word? Superstitious.
Skip to content. ChatGPT. ChatGPT. If I was going to be superstitious, what does 1010 mean? Attach. Search. By messaging ChatGPT, you agree to our terms and have read our privacy policy. ChatGPT. Free text-to-speech online with realistic AI voices. Speed dial. Skip to content. ChatGPT. ChatGPT.
It didn't even read the correct text. Come on.
If I was going to be superstitious, what does 1010 mean?
So I'm gonna chat about that. Really? I should get rid of the colon between. If I was gonna be superstitious, which I'm not. I don't know, here's what chatbot says.
If you're feeling superstitious about 1010, it's often seen as a powerful angel number or spiritual symbol with few common meanings. Spiritual awakening and growth. 1010 is believed to signal that you're on the path to spiritual development and self-discovery. It's like a nudge to pay attention to your intuition and inner wisdom, alignment with your life purpose. Seeing 1010 can mean you're aligning more closely with your true purpose or mission in life. Encouragement to stay positive. It's a reminder to keep your thoughts optimistic because your mindset shapes your reality. New beginnings and progress. The ones represent new starts and leadership, while the zeros amplify the energy and connection to the spiritual realm. Together, they symbolize moving forward with confidence. In short, 1010 is often seen as a sign from the universe, encouraging you to trust yourself and keep growing. Do you like these kinds of spiritual messages? Or are you just exploring for fun?
That's kind of funny. Dang it, did not build. Oh man. fuck's sake. This is not useful in any way. It's just this mismatch. It doesn't say where, for fuck's sake. I'm done for now. I have to like undo and fucking fuck. This is so stupid and annoying. I'll finish up tomorrow. I'm gonna have chat out text to speech, the ECMA saying or whatever. I'm gonna let the stream time out for 10 minutes so it sends the whole stream, because it doesn't always send the full stream. And then tomorrow, I'm gonna like start putting everything together. So I don't know, that's it for now. Peace.
15103 Prepare for tail call. The abstract operation prepare for tail call takes no arguments and returns unused. It performs the following steps when called. 1. Assert. The current execution context will not subsequently be used for the evaluation of any ECMA script code or built-in functions. The invocation of call subsequent to the invocation of this abstract operation will create and push a new execution context before performing any such evaluation. 2. Discard all resources associated with the current execution context. 3. Return unused. A tail position call must either release any transient internal resources associated with the currently executing function execution context before invoking the target function or reuse those resources in support of the target function. 6. ECMA script language. Scripts and modules. 6.1 Script syntax. Script body opt. Script body. Statement list. Yield. Await. Return. 6. 1. 1 Static semantics. Early errors. Script body. It is a syntax error if the lexically declared names of script body contains any duplicate entries. It is a syntax error if any element of the lexically declared names of script body also occurs in the are declared names of script body. Script body. Statement list. It is a syntax error if statement list contains super unless the source text containing super is eval code that is being processed by a direct eval. Additional early error rules for super within direct eval are defined in 192.1.1. It is a syntax error if statement list contains new target unless the source text containing new target is eval code that is being processed by a direct eval. Additional early error rules for new target indirect eval are defined in 192.1.1. It is a syntax error if contains duplicate labels of statement list with argument is true. It is a syntax error if contains undefined break target of statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments and is true, comma it is a syntax error if all private identifiers valid of statement list with argument is false unless the source text containing script body is eval code that is being processed by a direct eval. Note, for example, a tail position call should only grow an implementation's activation record stack by the amount that the size of the target function's activation record exceeds the size of the calling function's activation record. If the target function's activation record is smaller, then the total size of the stack should decrease. 64. ECMA International 2024. 6. 1. 2. Static semantics is strict. The syntax-directed operation is strict, takes no arguments and returns a boolean. It is defined piecewise over the following productions. Script. Script body opt. If script body is present and the directive prologue of script body contains a use strict directive, return true. Otherwise, return false. 1.3 Runtime semantics. Evaluation. Script. Empty. Return undefined. 6. 1. 4 Script records. A script record encapsulates information about a script being evaluated. Each script record contains the fields listed in Table 40. Table 40. Script record fields. Field name, value type, meaning, realm, a realm record or undefined. The realm within which this script was created undefined if not yet assigned. ECMA script code, a script parse node, the result of parsing the source text of this script. Loaded modules, a list of records with fields, a string, and a module record, a map from the specifier strings imported by this script to the resolved module record. The list does not contain two different records with the same host defined. Anything default value is empty. Field reserved for use by host environments that need to associate additional information with the script. 6. 1. 5 parse script. Source text. Realm. Host defined. The abstract operation parse script takes arguments source text, ECMA script source text, realm, a realm record or undefined, and host defined anything and returns a script record or a non-empty list of syntax error objects. It creates a script record based upon the result of parsing source text as a script. It performs the following steps when called. 1. Let script be parse text, source text, script. 2. If script is a list of errors, return script. 3. Return script record, realm, script. Host defined. Note an implementation may parse script source text and analyze it for early error conditions prior to evaluation of parse script for that script source text. However, the reporting of any errors must be deferred until the point where this specification actually performs parse script upon that source text. ECMA International 2024 365. 6. 1. 6 Script evaluation. Script record. The abstract operation script evaluation takes argument script record, a script record, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. 1. Let global env be script record. 2. Let script context be a new ECMA script code execution context. 3. Set the function of script context to null. 4. Set the realm of script context to script record. 5. Set the script or module of script context to script record. 6. Set the variable environment of script context to global env. 7. Set the lexical environment of script context to global env. 8. Set the private environment of script context to null. 9. Suspend the running execution context. 10. Push script context onto the execution context stack. Script context